Topic 5, organic chemistry. We have a lot, I'm not gonna waste time. خلاص, let's just start. Okay, this is the scariest chapter, especially for this periodic. As you can see, let me chop. يلا. Define the term homologous series. What is a homologous series? A homologous series are members of the same family. They have the same functional group, right? Okay, and what are 3 properties about them? Let's see. They all have the same general formula. They all show similar chemical reactions, right? Similar, keyword similar. And they have similar methods of preparation. Okay? Memorize. Okay? You need to know this. Question 2. Okay, question 2. Write an equation to represent the complete combustion of C3H8. C3H8, by the way, is an alkane. I'm gonna explain as I go, but I really explained these for the CA videos the past 2 weeks, so I won't spend too long explaining. Okay, once we get to alkanes, alkenes, and whatever specifically, that's when I'll start explaining properly. Okay, write an equation to represent complete combustion of C3H8. Remember, I'll go just really quickly over the topic 5 notes. Okay, over here. Over here when we spoke about combustions, somewhere here, hold up, yeah, here, combustions. So combustions, usually alkanes and alkenes, they undergo incomplete combustion, but that's not my point. A complete combustion and an incomplete combustion. Complete combustion reacts with oxygen to form carbon dioxide and water. However, an incomplete combustion is in the absence of oxygen. When there's not enough oxygen, it forms carbon monoxide and water. Okay, so CO instead. So over here, for the complete combustion of C2H8, we're going to react it with oxygen to form carbon dioxide and water, and balancing is just easy. Let's take a look. 3 carbons over here. You now have 8 hydrogens, 4 over here. If we have 6 plus 4, 10, so you're going to put a 5 over here. There you go. Let's take a look at the answer. Whoa. Is this not balanced? Carbon's balanced. Oh no, this is not. Okay, this is wrong balancing, huh? Because you can just divide by 2. It's correct, but you can just divide by 2. I don't know why they did it like that. Question 3, is the ethene molecule planar or 3-dimensional? It's not required, but it's over here. But it was in the notes. I think it was the first thing written up here. Somewhere here. Anyways, I couldn't find it, but it's a planar molecule. All of our alkanes, alkenes, whatever, they're not 3D, they're all planar. Ethene, by the way, you need to know how they look. Ethene, it's an alkene, right? It follows the alkene family, okay? And alkene is CnH2n, right? Type CnH2n. Eth stands for 2 carbons, right? So it's going to be C2H4, right? How does C2H4 look? It's an alkene, so it has a carbon double bond, HH, HH. And it's a planar. Okay, you need to know this. Okay, write an equation to show how ethene is produced from ethanol. Ignore state symbols in your equation. So I just had a quick thought. Since these are kind of not in order, I'm thinking of going through the notes and solving the CQDs there. Because they're the same as the ones here, but there's only a few missing. The ones that are missing, I'm gonna I'm gonna redo them afterwards. Okay, so I'll solve the ones in the notes because I want to explain as I go, and it's very hard to explain as you go when you're working with the course revision because course revision is scattered everywhere. Okay, so I'm gonna start over here. Okay, I'm gonna start with the CQD over here. It's what are hydrocarbons and which of the following are classified as hydrocarbons. It's the same answer key, by the way. Same as the course revision answer key. What is a hydrocarbon? It's something that contains only carbon and hydrogen. So which one of these are hydrocarbons? Obviously, it's going to be A and D, right? Okay, whatever. You need to know when something is saturated or unsaturated, okay? Because they ask this. Something is saturated when it has no carbon double bond. Okay, when there's no carbon double bond, it's saturated. Okay. When is it unsaturated? When you see this carbon double bond. This carbon double bond means it's unsaturated. If you want a way to memorize it, the reason behind this actually is when you have a carbon double bond, the molecule has no space to attract, like, I don't know what the word is. I'm not going to say, I actually don't know. I forgot it. But anyway, when it has a carbon double bond, it's already packed, so it can't attract extra weight. Okay, think about it like this. So that's why it's unsaturated. But the one with carbon single bonds, it can attract extra weight, so that's why we call it saturated. It's saturated with all that weight. Okay. Also, triple and double are both unsaturated. Okay. Whatever. La 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 la. Homologous series. We know what it is. Okay, this. You need to know this, right? Alkanes. Alkane, CnH2n plus 2. No functional group. That's why alkanes are mostly unreactive. You need to know alkenes, CnH2n, right? اتفقنا. What's the functional group? You know, it should be carbon double bond. Alcohol, CnH2n plus 1, OH. The whole, this HO, I kind of remember it like this, okay? And obviously it has an OH. Acids, CnH2n plus 1, but what's the functional group? COOH. So these are technically the same, but you just move the hydrogen here and added an oxygen, right? If you take one hydrogen out, it's going to be plus 1, right? So we just put it on the side and we put an O, so that's why it ends with an OH. And over here, CnH2n plus 1, we just removed it to the side and added COO to get the COH formula. Members of the same homologous series, what do they have? They have the same general formula, similar chemical properties and reactions, similar chemical reactions as well, same functional group, okay? Differ from the one before and the one after by 1 CH2 unit in case you see the multiple. Show a trend in physical properties, for example, melting and boiling point will generally increase with increasing carbon chain length. Okay. Define the term homologous series, list 3 properties. I'm just going to show you the answer, screenshot if you want, because we already did question 1, we did it already. Okay, over here. Alkanes. Okay, we'll start with alkanes. What is the general formula of alkanes? CnH2n plus 2. If you want to take notes, that could be a good idea if you don't already take notes for chemistry. Or if you want to, like, you know, I always advise you to write things down. Maybe create a small revision sheet for yourself. It helps out a ton with the organic because we have 31 pages left. Okay, this is going to be a long video. Alkanes, CnH2n plus 2. How long am I? I'm not far in. Yeah, CnH2n plus 2. You need to know they're saturated. So the ones that are saturated are the alkanes. Okay, it's saturated. It forms single, right? Since it's saturated, why? Because it's single. Okay, whatever. Okay, it is an unreactive hydrocarbon. You should know since it has no functional group, it's unreactive. Okay, give the general molecular formula for alkanes and give the molecular formula for an alkane having 3 carbons. Alkanes, what are they? CnH2n plus 2. Having 3 carbons, just plug in 3n is 3, so C3H8, right? Just plug in 3 as n. Let's check the answer key. Question 5, can it? Over here. Yeah, perfect. Nomenclature, okay. I want to see, you're probably gonna get naming in the periodic, okay? I think she's gonna get you naming, but I want to see if there's any questions in the course that ask about naming. So she didn't put any questions about it in the course revision, which is pretty surprising since it's in the notes and she put questions about it in the notes. I'm gonna explain it obviously and answer the questions in the notes because you need to know how to name, and every teacher stressed on it. So I'm gonna go through the naming and explain it for you one by one. Yeah, see over here in the written part, the past papers, there are questions where you have to name. I'm gonna go over the naming for each one, alkanes, alkenes, alcohols when I get there. For now, I'm just going to start with naming the alkanes. Okay, to name, I feel like I should do it. I should explain it like. I'll give you a few examples. Okay. Oh, bro, I swear, I think this was from before. This is from. I don't know why this is open. Subhanallah. I don't know how this is open. Anyway, I'll start with naming. Okay, you need to know this for your written part, because I might not be making a video solving the past papers. Apply what I'm teaching you here. Okay. When you have a compound, I'm not gonna draw it out CHH. Okay. If you see something like this, I'm just gonna write it as CH3. Let me create a new document. Okay. New document. I'm not gonna write CHHH and draw each one. I'm just gonna say CH3. Okay, let's say you have CH3, CH2, CH2, CH3. Okay, if you were to name this, it's an alkane because if you look at the formula, it's C4H68. Whoa, is it? It shouldn't. It's 6H10. Sorry. Right? طيب, this is an alkane. So if we were to name it, we remember methane, ethane, propan, butane, pentane, hexane, heptane, octane, none, decan. Okay, that's the song I memorized. Okay, remember methane, meth is 1, eth is 2, methane, ethane, prop is 3, bute is 4, pent is 5, hex is 7, so as the hex is 6, hept is 7, oct is 8, non is 9, and deck is 10. It should be written somewhere. It's not. Yeah, here. These are the prefixes. Okay, and it goes down hex, and then I'll continue it. Hept 7, oct is 8, non is 9, and dec is 10. Okay, you need to memorize these. Okay, like I told you, and I memorized it from the TikTok song. You can search up. What's it called? Organic chemistry prefix song on TikTok, and you should be able to find it. Anyway, so you have something like this. If you want to name it, it has 4 carbons, so it's gonna be bute. And since it's part of the alkane family, butane. Very easy. So let's say I came and wrote for you like this. Okay, and I drew a branch. Okay, this is where things get tricky. When you have a branch, this formula is over here. It's C5, 5, 6, 9, 12, right? You don't just simply call it pentane. This is a huge mistake. No. Okay? You need to know how it looks, because in chemistry, if I were to call this pentane, then this also will be pentane. This is pentane as well. Right? These are obviously not the same molecule. Our lovely chemists came up with a way to name it separately. Okay? They decided if you have a branch, you gotta follow 3 steps. Okay? The first step is count the longest chain. Okay? Count the longest chain. The second step, it's figure out figure out which carbon your branch is on. Okay? And the third step is apply number of carbon. Sorry, no, carbon. The branch, whatever. I'm gonna say N. N is the number, or is the carbon number that the branch is on. Okay, it goes like this. You apply this. N dash, okay, the name of your branch, okay, and then whatever chemical name. When I do this, it should make a bit of sense. Over here, figure out what's the first step when you have a branch. Count the longest chain. Let's see what's the longest chain. Okay, I'm going to draw 2 lines. You have this, right? That's 1 chain. How many carbons do I have here? When I say count the longest chain, it means count the chain that has the most carbons. And we don't care about hydrogens. Here I have 4 carbons. So is there any other way I can go? Let's take a look. Is there any way it can go better? If I do this, I only have 3 carbons. When I say chain, by the way, it means 1 stroke of the pen. I can't do this and call it the 1 chain. No. Okay? But this would give me 3 carbons. No, the other one gave me 4. So until now, that's the best one. This one now gave me 4 carbons. Okay? So, يعني عادي. But I'm gonna take, for practical reasons, this. Okay? This is our longest chain, 4 carbons. You can take the other one as well, it's fine, and apply the same steps. Type. We counted the longest chain. So our longest chain, we said what? 4 carbons. Type. Figure out which carbon your branch is on. Let's see. Let's start counting from left to right. 1, 2, 3. So my branch is on the 3rd carbon. طيب. What if I started counting from the right? You're gonna get 1, 2, and now your branch is on the second carbon. So which one do you choose? Do you choose the one which is the smaller or bigger? Smaller. Okay, so we're gonna say 2. Okay, you always need to check both, counting from the right and the left. And then 3, apply this. What's the number of carbon on? 2. You put 2 dash. If you don't put the dash, it's wrong. The branch. You need to know what the branch is called. This is now for your level. You're only going to face 2 types of branches. Okay, these 2. CH3, which is called ethyl. Okay, which you see most of the time. And if you see it, C2H5, I've seen some examples with it, but it's mostly ethyl. It's called methyl. Okay. Sorry, other way around. Other way around. Methyl and then ethyl. Because remember, meth is 1, eth is 2, right? Okay. 2. What's our branch name? Methyl in this case, right? We have CH3. Methyl. And what's our chemical's name? Let's take a look. How many carbons does it have? 4 carbons. So what is it called when it has 4 carbons and it's an alkane? What's it called? Butane. Right? So we say 2 dash methyl butane. That's how you know. Okay? I'll give, let's see. I'll give another example. I'll just move with the notes actually. Okay? So you can see here, I'll do this one. Here, let's count the longest chain. Always the longest chain. Just try doing this. We have 1, 2, 3, 4, 5. 5 carbons here. Let's try this. 5 carbons as well. No, but it doesn't count since this is CH2, CH3. This is counted all as 1. It's counted C2H5. Okay. Oh no, it's not actually. It's counted as 5 as well. Okay, and then this is 3. Okay, let's just take the longest chain. The longest chain is this one. So we have 5 carbons in our longest chain. So it should be something pentane. Right? It should be something pentane. Tab, let's take a look. How many branches do we have? We have 2 branches now. Right? So this is the first time we see this. So let's take a look. We said we start counting to see what number carbon it's on. 1, 2, 3, 4, 5. So if you count from the left, you get 2 here, and here's the 3rd carbon. Now let's start counting from the right. I told you you must always check from the right as well. 1, 2, 3, 4, 5. So obviously we favor the smaller one, so we're not going to count from the right. We're going to count from the left. Okay, so on carbon number 2, what do we have? We have methyl. Remember, CH3 is methyl. On carbon number 3, we have ethyl. So to name this, what do we do? You start with the heavier one. Okay, you start with the heavier one, ethyl. So you say 3 dash ethyl dash 2 dash methyl pentane. Type. You need to know you can't put a number connected to a letter in chemistry. You're not allowed. You have to always put the dash anytime you want to separate a number from a letter. You must. Okay? As you can see here, this is why they said it. Okay? Over here, they talked about if the same branch exists at different carbons. So here we had 2 different branches, right? Here, what's happening? They have the same branch, as you can see, 3 times. When you have the same branch, you use it either di, tri, tetra, whatever. Okay? Again, Anna, I'm explaining all this because she can bring it in there. I probably think she will. Okay? Trimethylpentane. Why? Again, let's follow our rules. What do we know? Take the longest chain. 5 carbons. It's 5 carbons, it's pentane. Type. Let's see our branches. Here we have a branch on the second. 1, 2, 3, 4, 5. Type. If you count from the right, it's going to be 3, 4, and we don't want that. Type. Let's take a look. 2 and 3, right? But they're all the same branch. Am I going to say 2 methyl, 2 methyl, 3 methyl? No. Since it's the same branch, I can just say tri. Okay? But since they're on separate carbons, you have to say the number of each. We have 2 methyl here, 2 methyl here, and 3 methyl here. When they're all the same methyl, we call it trimethyl. But for the numbers, we say comma, comma, and of course, when you want to separate a number from a letter, dash. Okay, and then pentane. Okay, since you have three, we say try, and since it's the same one, you separate them with commas. Like, okay, let's start with CQD7. Hexane C6H14 has 5 structural isomers. Draw the condensed structural formula for isomers of hexane and give the name for each. Yeah, as you can see here, she asked about the isomers. What is an isomer? An isomer is basically one that has the same chemical formula, different structural formula. Okay, so over here they said, look, isomers of alkanes. Okay, this is the definition, by the way. Alkanes with more than 4 carbons have isomers. What's different between an isomer and an allotrope? Remember the topic before we spoke about allotropy? The difference is that allotropy, it's chemicals that come from the same element. Here we're not talking about the same element, we're just saying they have the same formula but different structure. So let's take a look. Hexane C6H14 has 5 structural isomers. Draw the condensed structural formulas for isomers of hexane and give the name for each. I'm going to show you the solution. The easiest thing to do first is just draw hexane. Hexane, we know, they gave it to us at C6H14. You always start like this, right? But we never, when saying structure formula, we don't draw these bonds for the carbon hydrogen. We just say CH3. Always, always, always. For alkanes, it's CH3 at the start, CH3 at the end. Okay? CH2. We have 6 carbons, so we're going to do 6 times. It's 4, 5, 6. This is hexane. You want the first isomer? Just throw one branch in. The isomers come from branching, because when you branch, you get the same a different name, right? It's a different structure when you put a branch. So let's throw down a branch. How's it gonna look? CH3, CH, CH3. You can tell me, well, why isn't it just CH2, CH2? You can't. How is it gonna be connected to 2 hydrogens? فهمني. It can't be connected to 2 hydrogens, because look, CH2, 1. You have a carbon. Look, you have a carbon here. You have a hydrogen here. You have a carbon here. Okay, how is it going to be connected to another hydrogen and be connected to the C over here? You can't. So that's why we only connect it when it's part of a branch. It has only one hydrogen, and the other one down takes the third one. Okay, and then you continue like normal. 4, 5. Easy. Okay. How do you change the structure again? With one branch. Just throw this branch over here to the right. This becomes CH2. And now this bond becomes CH. CH3. CH2. CH3. Perfect. خلاص. So we have 3 so far. If you throw this now to the right, it won't be different. Why won't it be different? Because you're still going to be on the second carbon. Okay, here we're on the second carbon, right? 1, 2, 3, 4, 5. Here we're on the third carbon, right? So if you move it to the right, if you count now from the right, this is going to be the second carbon. Okay, but there's no point. In that case, when you're in this position, just get another branch. That's it. Take another one. Okay, it's going to look like this. CH3, CH2, CH. لا sorry, حتى مش CH. بلا ولا CH. No, you can't do CH. Because it can only bond to 3 things. Okay, we're going to put one CH3 above it, a CH3 below it, and continue CH3 like they did here. Okay, طيب, you can move this to the left, but it's still gonna be on the second carbon. Okay, you could move it to the start, but again it wouldn't work. Okay, so what do you do in this position? Just separate the branches. Take this branch to this carbon over here. How's it gonna look? Like this. CH3, CH, down you have CH3, here you have CH, down you have CH3, over here you have CH3. That's it. خلاص. How do you name these? Let's start with the first one. Well, the first one's obviously just hexane. Second one, you take the full branch. How many carbons is in it? 5 carbons. So it should end with pentane. On what carbon is your branch? It's on the second carbon. So you say 2 dash. And since it's 1 carbon over here in the branch, it's methyl. Okay? Over here, Same thing, 5 carbons in your branch, so it should be pentane, right? Since carbon, the branch is on the third carbon, so you say 3 dash methyl pentane. Over here, we have 2 branches, right? Take your first longest branch. How many carbons? 4 this time, right? So it's going to be butane, something butane. Let's take a look. On what number carbon is it? If you count from the left, it's going to be number 3. So if you count from the right, it's number 2. So 2 dash. What's our branch? Methyl. But how many do we have? 2. So you have to say dimethyl butane. The last one, our longest one is 4, right? So it's going to end with butane. Let's take a look. We have branches both at 2 and at 3. If you count from the right command, it's going to be 2 and 3. So it doesn't matter. If we're going to say 2, since it's the same branch, you're not going to say 2 methyl, 3 methyl. No, like I told you, when you have the same branch, you say 2, 3 dash dimethyl. Okay? When you have the same branch, you say di, tri, whatever. Okay? Since we have 2 of it, we say di. And since it's on 2 and 3, you say 2 comma 3 dash. Okay? Kind of long, but it's okay. Let's go. CQD2. Combustion of C3H8. I'll show you the mark scheme. But we did it already. Okay, we did it. Over here. Methane undergoes a substitution reaction with chlorine. What is the factor that speeds up this reaction? Remember, alkane, when it does chlorination, I did it somewhere here, maybe this one. No, over here. Yeah. So alkanes, when an alkanes can go through 3 reactions. Remember, combustion, cracking, and chlorination. Combustion is the easy one. Easy. Cracking is when it gets broken up into, when you have a long useless alkane, they break it and crack it into an alkene plus a smaller alkane. They just crack it up. Chlorination, okay? It also applies for bromination and fluorination. Okay? For alkanes, it's a substitution reaction. What happens? It replaces one or more atoms with chlorine. Like I told you, you have an alkane over here. Okay, what happens? You have alkane plus a ClCl molecule. Let me use my bigger piece here. Okay, let's say you have an alkane, CH4. It's the easiest one to work with. Okay, plus a chlorine molecule. Okay, you go and break it. Okay, what breaks it? The UV rays. This reaction can only take place in sunlight, in the presence of UV rays. Okay, they break the bond between the ClCl. It's now called a free radical. Okay, this free radical is so energetic. If it goes to the hydrogen, it's like, yo, get out. I'm not gonna let you stay there. Okay, if it goes, it kicks it out, and now our friend hydrogen over here goes here, chlorine goes here, and bam, we just did a substitution, like in football. Okay, what does this molecule become? It's now called, it was called methane, but since you have a chlorine in it, it's called chloromethane. And the more chlorines you have in it, dichloromethane, trichloromethane, tetrachloromethane. This is also called carbon tetrachloride, if they ask you. And what's formed? What's a product? Since they asked this as well, HCl, as you can see, right? So let's take a look. What is the factor that speeds up this reaction? Obviously, what's it called? UV rays. Okay, CQD8. Sunlight or UV rays. UV rays is accepted. Give the chemical equation. This is the equation. Right? I did it here. But I just used displaced form. Please know anything. Okay. The possible products, I'm going to list them for you. Okay. CH3Cl. CH2Cl2. Okay. CHCl3. CCl4. Okay. And HCl. Other than this, no possible products. Okay. Please. Don't pick anything else. Because it came multiple choice in the CA. What are the possible products of the substitution reaction? Type. Alkenes. Okay, alkenes, we know their general formula is what? CnH2n, right? And they said with 2 carbons, what is it? C2H4. Classify the following into saturated and unsaturated. Okay, how do we know something is saturated or unsaturated? It's unsaturated is عندك carbon double bond, right? Remember, like I said, you need to look at which one has a carbon double bond to know if it's unsaturated or saturated. Heptene, isn't this an alkene? Alkenes, do they have carbon double bonds? Yes. You need to remember one thing about alkenes is that they have the carbon double bond. Okay? Don't forget it. Okay? So is it saturated or unsaturated? Unsaturated. Okay? Hexane, it's an alkane, right? So it's saturated. C5H12. Okay, they didn't give you the name. C5H12. What formula is it? Is 12 double of 5? No. So is it an alkene? No. Okay? So what is it? It's saturated. It's an alkane, by the way, yeah? Because CnH2n plus 2. If you do double of 5, it's 10 plus 2, 12. Okay? Saturated. Because it's not an alkene. Propane, saturated. It's an alkane, so there's no carbon double bond. Cyclopentane, again, it's an alkane, so it's saturated, so no double bond. Yeah, that's pretty much it. You need to know, okay, this cracking, okay? Cracking, they don't have much questions on it, if I'm not wrong. Yeah. So, how do you prepare alkenes? What are the reactions of alkenes? You need to know for alkenes, you can produce them industrially and in the lab. Okay, but usually it's the industry that we look at. Okay, the first way to prepare alkenes is by cracking. Okay, so it's something I should have covered in alkanes, but I left it for alkanes because they're really related. When you have a big alkane, you use cracking. Since the alkane is so useless and it doesn't react, we crack it up to form a smaller alkane plus the alkene. Because the alkene is useful, it actually reacts. Okay, I mentioned cracking somewhere, yeah. So, oh, I didn't mention cracking. Really? Yeah, okay, yeah, cracking. No way I didn't say it. Okay, since I didn't mention it before, to do cracking, the way it works is you have a long chain alkane, okay, which just breaks down into basically a shorter alkane, a shorter chain alkane, plus what do you get? An alkene. And sometimes you get hydrogen gas, but we don't care about that. What do you need to know? You need to know the catalyst, okay? The catalysts are Al2O3 plus SiO2 at the same time. And the conditions for this are 500 degrees Celsius and 10 to 12 atmosphere. Or you can use Cr2O3, chromium oxide. Again, same conditions, 500 degrees Celsius, 10 to 12 atmosphere. Okay, remember these, please. Yeah, so that's the cracking. That's the first one. That's to prepare it. You can also prepare alkenes in the lab by dehydration of alcohol. Okay, I think they explained it here. Did they? No, they didn't explain. Okay, you can prepare alkenes. Yeah, over here, dehydration of an alcohol. Basically, an alcohol. Let me go to a new page. An alcohol is what CnH2n plus 1 OH. If you take H2 out of it, right? Dehydration. What if someone's dehydrated? It doesn't have water, right? That's how you remember it. Take out H2O out of it. Take two hydrogens out of it and one oxygen out of it. What are you gonna get? CnH2n, right? So for that reason, dehydration of an alkene, of an alcohol. This is an alcohol. Dehydration of an alcohol gets you an alkene. So for example, let's say you have ethanol. Okay, we're gonna go to the alcohols later. You're gonna and you dehydrate it. So you take water out of it. You're gonna get C2H4 plus H2O, right? And as usual, we have conditions. The condition is hot H2SO4 concentrated, right? at 180 degrees Celsius. Okay? I think she did it here. Or she didn't talk about it. طيب, okay, عادي. Forget about it. No, not forget about it. No, you need to know it. طيب. What do we need to know as well? Let's go to the reactions, okay? The reactions, alkenes undergo addition reactions, okay? They're mostly addition, okay? So an addition reaction is basically where you add something and you get one product, right? So the first reaction alkenes go through is combustion, but it's not written here. Oh yeah, it's written here. Okay, they all go through combustion. Okay, but alkenes are famous because they have addition reactions. What do you add? You have the most famous ones are hydrogenation and bromination. Okay, hydration is also one as well. Let's start with hydrogenation. Okay, hydrogenation, as the name states, is adding hydrogen. When you add an alkene, when you add hydrogen to an alkane, CnH2n. If you add H2, what's it gonna be? It's gonna become CnH2n plus 2. Okay, right? And what's that? Alkane. So these are all things you can really work out as long as you know the general formula. You don't have to memorize any of this. If you have CnH2n, add two H's, it's gonna come to n plus 2. And what is that? That's just an alkane. Okay, so alkene plus hydrogen gets you alkane, but you need to know the condition. Condition is nickel, presence of nickel at 200 degrees Celsius. Okay, you need to know this. Hydration, forget about the H2SO4, even though she may ask it. But I don't have it written in my notes. I think the famous one is nickel at 200 degrees Celsius. Addition of steam or hydration. Okay, just say hydration. Hydration from the term hydrated is means adding water, right? طيب, when you add to an alkene CnH2n and you add H2O, it's gonna become what? CnH2n plus 2O. And we know when you have an oxygen, it needs to be paired with the hydrogen, so we just make this plus 1 and do this. And what is this? An alcohol, right? So when you add water to an alkene, it becomes an alcohol. Okay, what's the condition? The condition is either H2SO4 at 80 degrees Celsius or H3PO4 at 300 degrees Celsius. I have it written here as well. طيب, these the pressure is 70 atm, huh? طيب, the last one is bromination or chlorination or fluorination. It works for Cl, Br, and F, huh? The addition reaction. What happens? Basically, this time with the chlorination, bromination, and fluorination, is it a substitution or addition? It's addition, right? As opposed to when we're working with alkanes, it was substitution. Here, it's addition, right? Are you gonna have one product or two products? It's one product since you're just adding it, okay? I'll draw it for you. Let's say you have alkene, say ethene over here. This is ethene, right? Let's say you're doing bromination, so we add a bromine molecule. Okay, what do you get? Since it's addition, what happens? There's no catalyst here, okay? But you need to know that basically this carbon double bond will break, okay? Freeing up space for the carbon to bond to more than one atom now. So what's it gonna look like? The hydrogens stay the same. However, you now have bromines. That's it. How would you name this? Okay, it's a branch, right? It's a branch. This is the longest carbon chain, okay, or it's methane, okay, but it's branched to Br. It looks like this, by the way, huh? In its structural formula would look like this. I drew the displayed, it would look like this: CH2 Br, CH2 Br, right? Type, this is your longest branch made out of two. Since it's an alkene, we're gonna say, never mind, it's not an alkane anymore. since you have the bromines and bromines. It's now considered alkane. Sorry. It's not an alkene anymore. It's now considered an alkane. Okay, so when you name it, okay, it's 2 carbons, so it's gonna be what? Ethane, right? So we have a branch on 1 and 2, right? So we're gonna say, since they're both bromines, we're gonna say 1 comma 2, and since it's two of them, two of the same one, we say dibromoethane. The conditions for this, by the way, is room temperature and the presence of CCl4. It has to be in CCl4. Okay. You need to know if you did this in water, the product you get, instead of having another Br bond, you see here we have 2 Brs, and OH will bond instead. Okay. You need to know this is different than the bromination, chlorination, and fluorination for alkanes. How can you tell it's different? Because this one can work in the dark, right? The other one can't work in the dark, the one for alkanes, right? Remember, it needs the presence of UV light. So this one, it can work in it can work in the dark. So you can read this if you want and you'll get it. Type polymerization. There's a whole section for polymers, so I'm not gonna spend too much time on it. But you need to know alkenes, okay? They add each other to form very large molecules, okay? These are called polymers. So basically, you know, alkenes tend to form polymers, okay? We're gonna talk a lot about polymers later on, but this is how it works. Okay, CQD3, is ethene planar or three-dimensional? Obviously planar. Write an equation to show how ethene is produced from ethanol. How do you get an alkene from an alcohol? Remember, it's a dehydration reaction, right? Ethanol is what? C2H5OH. How do I know? Because alcohol, CnH2n plus 1 OH. Just plug in eth, which is 2 carbons, as your n, and you're going to get this C2H5OH. Remember, it's dehydration of an alcohol. So what do? You remove water out. So you're going to get ethene, C2H4, plus H2. What are the conditions for dehydration? I know you forgot, but let's take a look at the solution. CQD3. Yeah, hot H2SO4 at 180 degrees Celsius, right? For hot H2SO4 at 180 degrees Celsius. H2 hot concentrated H2SO4 180 degrees Celsius. Type. Write an equation for the complete combustion of C3H6 and explain why the flame produced is colored unlike that of C3H8. Let's take a look. C3H6 complete combustion, so we're going to react with oxygen, and since complete combustion is going to form what? Carbon dioxide, carbon monoxide, obviously carbon dioxide, plus water as usual. Type. Let's balance. You're going to put the 3 here, 6 on, and x3, you have to put the 3 here as well. So you're going to put, you have 6 over here and 3 here, 9. So you can put 9 over 2. Then multiply everything by 2. This cancels. You're going to have 6 here, 6 here. So it should be 2966. Let's take a look. Yeah, 2966. Okay, that's just the balancing. Balancing is easy. Okay, why the flame produced is colored unlike that of C3H8? And I'm just going to open the solution because I don't know. Okay, the flame produced is rather smoky due to carbon, which is not burnt because of its high proportion. Okay, if I just understood why. Okay, basically, C3H6 and C3H8, they both produce dirty flames. Okay, but you need to know if a molecule has a higher proportion of carbon to hydrogen, okay, or higher ratio of carbon to hydrogen, then it's gonna produce what we call soot. It's like dirt, okay? It's like dirty stuff, okay? This is because the molecule has a higher proportion of carbon. They said it here. Because carbon has high proportion, but that's why it produces something called soot. Okay, it's smoky. Okay, it's like disgusting stuff that comes out of it, and so the flame looks dirty. Okay. So what do you need to know whenever they ask something? Why would something be clean and another one be dirty? Because it has a higher proportion of carbon in the molecule. طيب. Let's see here. Write equation showing what happens when C2H4 reacts separately with hydrogen and hydrogen chloride. Give the name of the product in each case. What name is given to this type of reaction and why? Okay, let's take a look. C2H4 is obviously an alkene, in specifically it's ethene, right? When it reacts with hydrogen, what happens when when an alkene reacts with hydrogen? It's called hydrogenation, right? And when it reacts with hydrogen chloride, what happens? I think, would it be counted as chlorination? I think it's chlorination, hydrogen chloride. Let's see. So obviously, reactions are what type of reactions? Obviously, they're addition, right? So they're both addition reactions. I think they asked it. This type of reaction is addition. Why? Why do we call it addition, guys? By the way, because you have one product being formed. Okay. Yeah. Here. Yeah. Exactly. This one was chlorination. So C2H4 plus H2 hydrogenation, you get C2H6. Oh, what's this? Ethane, right? Ugh. C2H4 plus HCl, you just add it. Chloroethane. That's it. Someone's gonna tell me why is it called ethane? Oh, never mind. You're gonna tell me why is it an alkane now? I'm telling you, when you do an addition reaction of an alkene, any addition, let it be hydration, hydrogenation, um, chlorination, bromination, you're always gonna have to switch it to the alkane family. Okay? Write equations showing what happened. Okay, we did this. How can you distinguish between ethane and ethene? Write equations for any possible reactions. The first thing that comes to my head is that for chlorination C2H6, you need UV light, you need sunlight, but C2H4 since it's an alkene, you don't need sunlight. You can do it in the dark. So let's take a look. What? Ethene decolorizes bromine while ethane does not. Yeah, so basically it's the same thing. Like I said, bromination occurs with the alkene عادي, but for the alkane it needs sunlight, so there will be no reaction. So it was actually written here in an explanation. This reaction, the bromination for an alkene, it used to differentiate between saturated and unsaturated, and basically between alkanes and alkenes. How? Because mixing alkenes, unsaturated hydrocarbons, you guys know alkenes, with bromine water rapidly decolorizes in the dark. However, for an alkane, it doesn't react in the dark. CQD9. Give the structure formula for the product of each of the following reactions. Type, let's see. What's this C2H4? It's ethene, right? We're adding water, so it's gonna be C2H4 plus water. It's gonna be what? C2H6 O. But you know when you have the O, you have to remove one hydrogen, put it then. So C2H5 OH. Isn't that an alcohol? Yes. Awesome. So this proves our rule. Alkenes undergo hydration reactions. This is part of one of the addition reactions that we spoke about, right? So what's it gonna get? You're gonna get since addition, you should only get one product, huh? One product, which is C2H5OH. So CC, C2H5OH. So you should have H, 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 and the last one will be OH. Not hard. Okay, let's take a look. CQD9. Yeah, it can be anywhere, huh? Here Br2 again bromination, so it's gonna be what? CC, H, H, Br, Br, H, H. Yeah, or like this عادي, it's fine as long as they're not on the same carbon, no? Last one here, you have what seems to be, don't be scared, it's still an alkene because you have the double bond, right? Also, this is just what? C3H6. C3H6 plus hydrogen, what do you get? C3H8. So don't panic, just add hydrogen, just add 2 hydrogen. C3H8 looks like this. H, 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 H. So not that hard, huh? So far so good. هيك نكون خلصنا من الالكينز. هلا alcohols. Okay. Alcohols. I had to take a small break because This is an interesting recording. We're 50 minutes in and we are far from being done. No, actually we're halfway done. So yeah. Alcohols. I'll go a bit faster because we all have lives. Both me and the person watching the video. So let me try and wrap it up. General formula is CnH2n plus 1 and its functional group is OH, right? What is the general formula for alcohols? CnH2n plus 1 OH. And the molecular formula, for one having two carbons, just plug in NS2, you're going to get C4H5OH. Like alkenes, whatever, okay, they have branches and there's naming of alcohols as well, okay? It follows the same naming system as everything else, okay? But you need to know for alcohols, it's kind of like, it's how can I say it? There's a specific way for naming alcohols, okay? Again, I'm not gonna follow the notes way because I'm gonna use my way. I'm gonna go step by step, okay? The first thing you need to know about naming an alcohol, it comes from two groups, okay? So we're gonna start with CH3OH, okay? This is called methanol, but the long name for it is methyl alcohol. Yeah, I just had to go over my notes for a sec. Yeah, anyway, for one carbon, for obviously methanol, or we say methyl alcohol, okay? Because it's a CH3OH. Yeah, CH3, remember, is methyl, right, guys? Remember from the branches, CH3 is methyl, C2H5 is ethyl, if you remember. Anyway, this is the easy one. But you're gonna see stuff that are different, as usual, okay? You need to know how to deal with them. So I'll give you an example like this, okay? Let's say I gave you this, okay? This is C3H7OH, by the way, okay? HHH. Type. This is a normal propanol molecule, right? It has three, so we would call it propanol. But the thing is with alcohols is this OH molecule matters, okay? We need to know where it is. So you're gonna do as normal, okay, propanol, but you just need to you need to mention where the OH is, okay? So over here, the OH is where? On the second carbon, right? 1, 2, 3, it's on the second carbon. But what do we call it? We just say 2-propanol, okay? But for written parts, you can write this is accepted. But most of the time, actually, if you look at marking schemes, they don't say this, they say this. Okay, they say it like this. No, sorry. Propan dash to all. Propan dash to all. Because all this is the group that's on the branch. Okay, if you look at any IGCSE marking scheme, they don't accept this. Okay, maybe they might accept it, but the answer they want, they look for this. Okay, so for IGs, and especially come on our exam, if you look at the past papers she put, these are the answers for them. Okay, yeah, and this is how we do it. Let's say I have butanol. Okay, I'll just do it like this. Okay, CH3, CH2, CH over here, H2, and it's bonded to OH. Okay, let's see. Here, our OH is on the fourth carbon, but if you start counting from the right, it's on the first one. So, what is our molecule here? We have 4, so it's butanol, right? Since it's on the first one, we just say 1 dash. But remember, we don't do this. Okay, I'm gonna stop saying it like this. I'm gonna start saying it all in this form. Okay, you can say it like this. So let's say I came and I put it over here, and I made the molecule look like this. CH3. Okay, right now again it's butanol, but our alcohol group, our hydroxide group, is where it's over here on the second carbon, right? If you start going from the left, it's 3. But if you start from the right, it's 2. We're going to pick 2, obviously, right? So what's it going to be? Butan 2 all. This is very important. You need to know the difference between these two molecules. Okay? Please. Type. So they don't really stress too much on the ones here for alcohols. Let's go. Okay, how do you prepare alcohols? Obviously, fermentation is the first one, where bacteria undergo, as the yeast undergo fermentation. Glucose breaks down to ethanol and carbon dioxide. You need to know you need to do it between 95 and 35 degrees Celsius. Easy stuff. What's the condition of fermentation? You need to know absence of oxygen. That's the most important one. A yeast and 25 to 35 degrees Celsius. You need to know that it's a self-limiting reaction because it ends when the yeast dies, right? Because when there's too much alcohol, the yeast dies, right? So when the mixture reaches around 14. And then how do you extract it and purify that alcohol? You need to know it's purified through fractional distillation. These are all previous CA questions, huh? Okay. How do you produce an alcohol? Remember when we talked about ethenes, we said you can do hydration and add H2O, right? So when you do C2H4 and you add H2O, for as an example, you can get C2H6O. But I told you the O doesn't stand alone. It has to be like this, right? Isn't this just ethanol? It is. Okay, so this is one of the other ways, and we said the conditions are H3PO4 at 300 degrees Celsius / 60 to 70 atm, or hot concentrated or just concentrated H2SO4 at 180 degrees Celsius. They meant to write it here as well, huh? Sorry, مش 180 80 degrees, huh? Okay, sorry. So either this H3PO4 at 300 degrees or concentrated H2SO4 at 80 degrees Celsius. Okay, anyways, but the one they ask for usually is this. So if you were to write one, write H3PO4 at 300 degrees Celsius at 60 atm. So no, just in case they asked you the other one, you should not. Type. Comparing the two methods, fermentation, there's the lab method and the industrial method. Okay, obviously, you can read over this if you want. So I'm gonna continue. What can you use ethanol for? Okay, as a fuel. Okay, this is the reason why. So you should. This is they ask for these most, right? No, they don't ask why. They ask what are the uses. What do we use ethanol in? Fuels, solvents, beverages, obviously like wine, alcohols, and the raw material to make other compounds. Okay, so please read over this if you want. And this is Zabel. They don't ask this in our exam. Actually, no, you know what? Last time she did ask in one of the periodics. One of the reasons was something stupid like this. Obviously, someone would choose the lab method or the industrial method based off the availability of resources. If a country does not have abundant crude oil, then obviously they're going to use fermentation to produce ethanol. Because the industrial method is the hydration method, huh? Or the lab method is the fermentation method. Okay, كمان if pure ethanol is required, then obviously they use hydration. You need to know hydration, it gets you pure. Okay, read over this, huh? Don't skip it. Seriously, read over it. If you need pure ethanol directly, then obviously the hydration method will be better and faster حتى. Okay, because fermentation, remember, it gets you a not pure solution of alcohol. You have to do fractional distillation after it. طيب. For the production of wine, only dilute ethanol is needed, so fermentation is a good choice. Okay, so maybe she might ask you which method is used to produce wine, the industrial method or the lab method. You would say the lab method, fermentation. Ethanol can be prepared biologically from glucose. Name the biological process of preparation of ethanol from glucose. Obviously, it's fermentation, right? Let me open the marking scheme for you. It's fermentation. Give the chemical equation for this process. Okay, you should just know it's glucose C6H12O6. I think everyone knows the formula of glucose. Anyone who did basic biology should know it. Breaks down to form what we said, an alcohol C2H5OH and carbon dioxide, right? Type, balance it. You have 3 here. If I put how many hydrogens? 10. You should put the 2 here, and then put the 2 here. Yeah, it's balanced like this, I think, right? Yeah, 2, 2. Okay, what are the conditions needed for this reaction to occur? Obviously, the absence of oxygen being the main one, as well as the yeast, obviously, and 25 to 35 degrees Celsius. Absence of air and yeast, and 25 to 35 degrees Celsius. Suggest a technique to separate ethanol from the final solution. How would you separate it? Remember, you need to do fractional distillation. Okay, again, like every other organic compound, it undergoes combustion. Okay, you should know that ethanol, it's the same thing, and the complete combustion, whatever. Ethanol burns with a clean flame. You're gonna ask why? Because look at ethanol. It has an oxygen in it. Okay, I think about it like this. But since it has this oxygen, it's gonna, you guys know combustion happens easily in the presence of oxygen. Okay, since it has this oxygen, it's gonna be nice and clean. Okay, oxidation of alcohols. This is another method to prepare another reaction that alcohols undergo. Basically, when it oxidizes, okay, it forms what we call a carboxylic acid. Okay, the carboxylic acid has the formula CnH2n plus 1 COOH, which we're gonna cover in a bit, don't worry. But you need to know this reaction as well. Okay, but you know it needs to be present it needs to be in the presence of an oxidizing agent, such as KMNO4 or CR2O7, K2CR2O7, sorry. Okay, you need to know the colors. Okay, the colors, it changes from purple to colorless, the KMNO4, and if you ask about potassium dichromate, the K2CR2O7, changes from orange to green. This was a previous CA question, I remember it. Color changes from purple to colorless. And they asked you what are the products, you just had to say the acid, I think it was ethanoic acid in the exam, and water. Okay, nothing else. And the last reaction, other than combustion and oxidation, that alcohols go through is what we call esterification. Basically, what you need for esterification is pretty simple. You need to know this reaction. Acid plus alcohol gets you ester plus water. Don't stress too much about it. We're gonna go now to esters in a bit. But you need to know acid plus alcohol is ester plus water. So when we add the acid to our alcohol here, you get an ester. Give another name for methanol and ethanol. Remember, we can call them methyl alcohol and ethyl alcohol, right? So methyl alcohol and ethyl alcohol. Ethanol is produced from sugar by fermentation. Fermentation produces a dilute solution of alcohol. How can it be concentrated? You have to do fractional distillation, right? There you go. Write an equation to show how ethanol is produced from ethene. What conditions are needed for the reaction to occur? Now, what do we do? You want to find C2H5 ethanol, but you have C2H4. What do you have to add? Let's say you don't know. What do you do? Compare them. You need H2O, right? So what do? You now know that you have to add H2O. Let's say you don't know it's called hydration or anything. You don't know anything. Just compare the two molecules. What do you need to add to C2H4 to get C2H5OH? Okay, so you get C2H5OH. What conditions are needed for this reaction to occur? H3PO4 at 300 degrees Celsius and 60 to 70 atmosphere, right? Let's take a look. In the presence of phosphoric acid. Phosphoric acid is H3PO4, huh? Okay. Part D. List 3 common uses of ethanol. We said in beverages, as well as fuels and energy sources. And one last one was, I forgot what was the last one. Fuel, perfumes. Okay, yeah, perfumes, drugs, and surgical spirit. Okay, these are correct, as well as the ones up here, huh? If it came written. Okay, beverages and spirits, solvent, and fuel. Okay. Okay. Well, they don't know why they said solvent. Okay. Part G. So shakli, why she skip E and F? What's E and F? What questions is 11? What gas is produced when ethanol reacts with okay, you don't need this. Okay, F as well, you don't need it. What is produced when ethanol is warmed with a suitable oxidizing agent? What happens when you oxidize an alcohol? What do you get? You get a carboxylic acid, right? So you get ethanoic acid. We're gonna now move to carboxylic acid and talk more about that. But always know the carboxylic acid, it's something acid, something IC acid. Ethanol would be ethanoic acid. Methanol will get you methanoic acid. Propanol will get you propanoic acid, and so on and so forth. Okay? Yalla. Carboxylic acids. The general formula is RCOOH or CnH2n plus 1 COH. This is the one you guys are familiar with. I'm going to explain this one over here on the left. Basically, every carboxylic acid looks like this. Okay, CnH2n plus 1 bonded to C, double bond O, OH. Okay, this is how it looks. You need to know it's a double bond O. Huh? Okay, sometimes they may write it for you like this. The O bonded to the H like this. Adi, that's completely fine. But what do we replace it? Since every carboxylic acid has this CnH plus 1, we call it R. Okay, it's called the radical. Okay, not right. We just call it the R group. Okay, so this is what they meant with it. Okay, please make sure this is a double bond. Okay, you need to put it as a double bond. Okay, what's its functional group? Obviously this COH. Okay, type. Preparation of acids. How can you prepare it? We spoke about one over here, right? The oxidation of an alcohol. That's one. So we can say by oxidation and so by the oxidation of alcohols. That's the first one. How can you do it? You need an oxidizing agent such as KMnO4 or, like they said here, K2Cr2O7, right? K2Cr2O7. Or like we said here, where did I go? KMnO4. Okay. How does the process of it go? Oxidation. The ethanol is mixed with potassium manganate solution, or like we said, potassium dichromate K2Cr2O7. It could be either, and heated in a round bottom flask under reflux. The condenser is set up in a vertical position to prevent the alcohol from escaping because it's volatile. Remember that alcohol is highly flammable and heating should be done with extreme care and never with direct flame. By the way, you should remember the temperatures. Oh, they didn't mention, but you just need to heat. Okay, as you can see here, in case they get this picture in the exam, huh? So you heat the ethanol potassium manganate, it's gonna oxidize and get you carboxylic acid. Okay. Reaction of acids. Okay, how do acids react? We're familiar with the reaction of acids, right? The first one is the dissociation of an acid. Remember we had HCl. What does dissociate into? H plus and Cl minus, right? Same thing with the carboxylic acid. How does it dissociate? The hydrogen goes and the rest is just minus. Very, very easy. Okay, the rest. Acids, we know they react with metals. We know they react with metal hydroxides and metal carbonates. This comes from chapter 3, salt preparation. You guys remember, right? The reaction of metal plus acid gets you gets you salt plus hydrogen gas. Metal plus metal hydroxide gets you salt plus water. Metal plus metal, the acid plus metal carbonate gets you salt plus carbon dioxide gas plus water. Remember these? So let's take a look here. Ethanoic acid plus magnesium gets you magnesium ethanoate, the salt plus hydrogen gas, right? And then with metal hydroxide, the acid plus sodium hydroxide gets you sodium ethanoate, the salt, plus water, and then here plus calcium carbonate gets you this carbon dioxide, so calcium ethanoate. There's a rule for naming the salt when it's with an acid of the organic one. It's basically the metal plus the number of carbon atoms, 8. Okay, so here it's one carbon atom. Sorry, here's the 2 carbon atoms, so we say ethanoate. Okay, what's the metal? Magnesium. So we just say magnesium ethanoate. CQD14. Name and give the molecular and structural formula for the first 3 organic acids. What are they? We have the first one is obviously meth, so methanoic acid. The second one is ethanoic acid. Where am I now? Then we have propanoic acid, right? Because 3 is prop. What are the structural formulas? Methanoic acid is CH2OH. Yeah. Ethanoic acid is C2 H5OH. No, wait, no, this is wrong. CH3 COOH. Yeah, this is right. Then C2 H5 COOH. And then C3 H7. Sorry, H9. Sorry. Never mind. It's 7. أنا مسطل يا عمي. If you just plug in the formula CN H2N plus 1 COH. Okay, what's the structure formula? I told you, for the carboxylic acids, it looks like this. R group bonded to COOH and double bond O on top. What's our R group? Over here, what is it? CH3. What's CH3? It's just like this. Right? Isn't that it? Since we have a lot, they told us to draw the structural, not the displayed. So the structural will look like this. CH3COH. So it's just this, no? Well, what number is this? 14? They actually want us to draw it? Okay. So I made a mistake here. What's unique about the carboxylic acids? CnH2n plus 1 COOH. So if n is 0, this will be 0 obviously, but you're still gonna have a carbon here. So that's why the first one, methanoic acid, actually looks like this. Let me do them again. Methanoic acid, you should know with carboxylic, it's one carbon, right? So if I took n as 1 for methanoic acid, it would look like this. Is this correct? Do I have one carbon here? No, I don't, right? So methanoic acid is actually when n is equal to 0. So for carboxylic acid, it starts at n equals 0. Okay, if n equals 0, you're gonna get this. Okay, and then ethanoic acid, I won't write it all. This is gonna be CH3COOH. Okay, and then propanoic acid will be C2H5COOH. Okay, let's draw them. HCOH. How do you draw it? It's just hydrogen bonded to COH double bond O. How did they draw it? Yeah, okay, same thing. And then this one here, CH3COH. Same thing. Draw CH3 bonded to COH double bond O. Okay, like this. Not that hard. And the last one, C2H5. Just draw C2H5. C2H5 is like this, right? This is C2H5 bonded to COOH double bond O. Just like that. This is a H. So as you can see here, this is it. Okay, not that hard, yani. They're all not hard really, but it's just a lot. Wallah, so much, and I'm getting tired recording. أقسم بالله. 1 hour and how much? So I had to split up the recordings. Anyway, but you're gonna see it as one recording. Part B, what methods can be used to prepare ethanoic acid? How do you prepare acid? We said oxidation of alcohols, right? So part B, it's oxidation via an oxidizing agent and bacterial oxidation during vinegar production. We said them here. See here? Part C, write an equation to show how ethanoic acid can be produced in the lab. Okay, you have to use the oxidation equation over here, this one. Remember, with carboxylic acids, ethanoic acid is 2 carbons, but that doesn't mean n equals 2, it means n is equal to 1, huh? Please don't mix up with it. So ethanoic acid is this, but here n equals 1. Remember, for carboxylic acid, it starts at n equals 0, that's why. Okay, so what methods can be used to prepare ethanoic acid? Obviously, you're gonna start, it's oxidation. It's oxidization of an alcohol, right? What's the alcohol you're gonna use for ethanoic acid? Akid ethanol, right? So C2H5OH. You're gonna oxidize it, that means put this O here, okay, to produce ethanoic acid. So CH3COOH. Is there anything specifically you want to write? Ah, okay. Okay, just to translate this stupid solution, um, this works. Okay, this works. But what they did here is they put the oxidizing agent, which is K2Cr2O7. Okay, I remember you can use KMNO4 or K2Cr2O7. So they put it and they just dissociated it. Yeah, اسحب. Okay, just know the oxidization agents, which are K2Cr2O7 and the KMNO4. Okay. What conditions are needed for the reaction to occur? What are the conditions? It needs to be in the presence of dilute sulfuric acid. Okay, you need to know this. So the condition for the oxidation is presence of the oxidization agent such as KMNO4 or K2Cr2O7 or bacterial oxidization. But the ones with K2Cr2O7 and KMNO4, they need the condition for them is to be in present. What should be present? Concentrated acid. Okay, as they dilute sulfuric acid. What gas is produced when an ethanoic acid reacts with zinc? When you react an acid with metal, what gas do you get? أكيد hydrogen. Hydrochloric acid gas, huh? طيب, I don't know. Okay, hydrogen gas. That's the answer. اسحب this one. I don't know where they got PCl5 from. Ethanoic acid, CH3COH, can be prepared from ethanol, C2H5OH, or ethanal, C2H4O. Identify the type of such reaction. When you go from alcohol to ethanoic acid, also what's the only way that we can get a carboxylic acid? Through an oxidation reaction, right? Oxidation reaction. Which of the following reagents are needed for the preparation of ethanoic acid from the alcohol? Obviously, it's these two. Okay, we need the dichromate solution and permanganate solution, right? These two, K2Cr2O7 and KMNO4. Okay, esterification. You need to know about esters that there's a section on it. Did they start esters? Oh no. Okay. You need to know. Excuse me. You need to know esters. They're sweet smelling. Okay. Alcohols react with acids. So the alcohols react with carboxylic acids to get esters. Okay. You know they smell like sweets. Okay. This reaction requires an acid catalyst, usually sulfuric acid, concentrated sulfuric acid. Okay. Whatever. To name an ester. Okay. You use the alkyl group of the alcohol plus the number of carbon atoms for the acid. Oh wait. Okay, so let me show you. Let me give you an example. Okay, yeah, CH3COOCH3. Okay, if I reacted for you methanol plus ethanoic acid, and I ask you to name the ester that's formed, what do you do? It's something YL, something O8. Always. This something comes from the alcohol. What's the alcohol here? Meth, right? So you put meth. So this one comes from the acid. What's the acid here? Ethan. Yeah, ethanoate. So you're gonna get methyl ethanoate. Okay? You should know that different combinations of alcohols and acids can produce esters that are isomers. For example, ethanol with propanoic acid and propanol with ethanoic acid. If I came and swapped these two, methanol ethanoic acid. Let's say جبت لك ethanol and methanoic acid. You're still gonna get this, by the way. You're still gonna get this same formula, same number of carbon, same number of hydrogen. But what's the difference? What's the name now? What's it gonna be called? It's gonna be called ethyl, using the rule I showed you 1 minute ago. Ethyl methanoate. Right? But is this okay? They have the same formula, but do you think it's the same thing? No. Okay, so using different combinations, you get a different name. Okay, so if مثلا I saw a question, in the CA, I remember it came. Methyl ethanoate, they gave you the alcohol that produces and the acid that produces, and they went and asked you, type which alcohol and acid would be an isomer of it or have the same structure as it. Okay, basically you needed to look at, it wasn't just swapping the meth and eth. No, actually what you had to do in the exam was take a look at the sum. Meth is 1, eth is 2, so the sum is 3. You had to look for 2, it was multiple choice, you just had to pick one of them. 2 that had to sum up to that. I think I have the question somewhere, wait. Yeah, so they gave you propyl ethanoate and they asked you which two which two acids and alcohol will give you a structure similar to propyl ethanoate. Okay, so you had to look, and propyl is 4 and ethane is 2. Sorry, this is 3, not 4. Ethane is 2, right? So you had to look and choose which one. The correct answer was this one, because butane gives 4 and meth gives 1. So they both add up to 5. Okay, you're supposed to pick one that adds up to the sum of these two. Okay, this is 5, so you had to pick one that has the sum that's 5 as well. Okay, I just went and got that. Okay, let's continue. Draw the general structural formula of an ester and circle the functional group. What is the functional group of an ester? I low-key don't know. Well, let's take a look at the solution. Esters. What's this? Okay, for the functional group is this. Okay, how it works is, let's show you. Let's go up to the reaction. So how do you get an ester? You add an alcohol to an acid, right? So let's see our alcohol here. This is the alcohol, and this is the acid here. Is it? No, this is just two alcohols together. What? No, never mind. Sorry, this is the acid. I didn't see the double bond O. Yeah, remember double bond O and then OH is the acid. This one here is the alcohol. Acid plus alcohol. So basically what happens when you form an ester, these two, okay, they form water. Okay, they form water and they get out. Okay, and then you're left with, just join these two. What's left? This C double bond O and this C bond together. Okay, so the functional group is this. Okay, someone might ask, where do you get this oxygen from? Man, this is OH, it came here. Okay, the O. Okay, this is how the functional group looks. C double bond O and then with another O. Let's memorize that. Okay, that's for esters. For the functional group for esters is C double bond O. Okay, when the general structural formula of an ester and circular function. What's the general structural formula? Yeah, it looks like this. Okay, so how the ester looks, take a look at how the ester looks. This here, it's the radical bonded to C double bond O, OH, right? Then here is the other radical, let's just call it R prime, bonded to OH, right? نحن اتفقنا this OH and OH, we take out 2 hydrogens and 1 oxygen, and you're gonna be left with what? R bonded here to C, bonded to, let's say I took out this hydrogen and this OH, okay, you're gonna be left with C bonded to, now what's left? O, right? Bonded to R prime, and this double bond O. Okay, but this is how it looks. Okay, why am I using R? Because it's too much drawing. If you want to see how it looks, take a look here. The function, not the general group of the one molecule bonded to the C double bond O functional group bonded to the general group of the second molecule. Question وين احنا? List, yeah, okay, and circular functional group. So we did part A. I showed you why. List 2 common uses of ester. Well, I showed you why. R bonded to R prime in the functional group. 2 common uses of esters: perfumes and artificial flavoring in some foods. Okay, they're used in perfumes. This came in an exam. Okay, which ester will be produced with ethanol and methanoic acid react? Remember, you take the YL and OAT, right? The YL comes from the alcohol, so ethyl, and then methanoic acid, so it's going to be methanoate. That's correct, right? Okay, and part D, I can't see it. What question? 16? Olive oil is made of a long chain of acids. What common name is given to the substance produced by oil? Okay, forget about that. She didn't include for a reason. The following equation represents the reaction between ethanoic acid and propanol. So acid plus alcohol. So this came actually in the exam. Give the name of this reaction. This is called esterification, right? Draw the structural formula for product A. How would product A look? Remember, to find out for esterification, we take this, right? We're going to remove that out, take it out as one water molecule. So how is it going to look now? Like this. Over here, right? Just remove this and continue drawing the molecule. Wallah ma بدها halal. You just have to remove it and continue drawing. Okay? Copy everything, huh? Just copy it. Wallah, I'm not drawing from myself. I'm looking here and copying it. It's not that hard. This is how the product will look. We just had to remove the water, right? Tafana, we remove the water for esterification. And it looks like this. Okay? Yes. Give the name of the product A. Since we're using ethanoic acid and propanol, remember the YL comes from the alcohol and the O8 comes from the acid. YL, what's gonna be? Propyl. What's gonna be the O8? Ethanoate. Okay. Part D. Compound B has the same molecular formula as A. Choose the name of the carboxylic acid and alcohol that react to form compound B. Like I told you, propyl ethanoate, right? You can just swap the propyl and ethanoic acid and use propanoic acid and ethanol. That works, right? But in the exam, sometimes they don't just swap them. What they care about, what's the most important part, is the sum of carbons is the same. Here, ethanoic 2, prop is 3. So in this case, the sum is 5. فإذا I came and put for you butanoic acid and then methanol, this would be correct since this is 4 and this is 1. Okay, or maybe methanoic acid and propanol. Sorry, butanol. This is 1, this is 4, so the sum will be 5. So what I'm trying to show you is that what counts is the sum. Okay, here the sum is still 3, 2. Hello, we're done from the organic part of chemistry. We're still in organic, but now we're into less compounds, more applied stuff. Yeah, let's start. Fuels, okay? You need to know fuels is very easy, okay? Fossil fuels, you can read this, whatever. But I'm gonna go straight to solving questions, okay? Petroleum and coke are considered fossil fuels. Are they renewable or not? Obviously, they're not renewable. What's the explanation? It's because they need over millions of years to reform. Okay? Okay, you can read this, but I'm gonna explain this, okay? Basically, let me go up to explain this first. Fossil fuels, okay, you need to know first, fossil fuels, where they say fossil fuel is somewhere here. Okay, it didn't. But you need to know that fossil fuels are made out of 3 main categories, okay? What are they? The first one is petroleum. Petroleum. The second one is natural gas. And the last one is coal. Okay? What do you need to know? You need to know that this petroleum, it's also called crude oil. Okay? Okay, and you need to know that it's black and sticky and thick as well. Okay? Natural gas, you need to know that it's basically methane. Okay? And coal is just black rock. I think you guys all know what coal is. Okay, made out of carbon mainly. Okay, what's the point here? Okay, the main point is this crude oil here. You need to know that 90% of petroleum, okay, is used for fuels. Okay, and to use it as fuels, it needs to be refined. Okay, it must be refined. Okay, how? There's two methods. The first is fractional distillation, and the second one is purification. Type. So as you can see here, I'm just reading over whatever. Okay, 90% is used to make fuels. It needs to be refined, and there's two processes for it: fractional distillation and then purification. Okay, you need to know how it works. This petroleum, to refine it, we do fractional distillation. We go into a place called the fractionating column. Okay, the vapors. Okay, so basically you heat it very, very hot. Okay, very simple. You heat over here at the bottom. According to their boiling point and melting points, they're going to become liquid and leave. Okay, you need to know that boiling point. As you go up, the boiling point decreases. Okay, or if you want to think about it another way, as you go down, the boiling point increases. Think about it, as you go deep into the chamber, it's very hot and the boiling point increases. What else happens as you go down? The number of carbons increases. So the ones with more carbons are usually the ones at the bottom. The viscosity increases. What's viscosity? It's basically how thick and dense the liquid is. And volatility decreases, which is pretty self-explanatory why it decreases. Akid, if something has higher boiling point, then it's less volatile. Volatile is the ability to change state. Since it has high boiling point, and akid, its volatility will be low. Then it needs a lot of energy to change state. Akid, it won't be volatile. Okay, that's pretty much it, by the way, for fuels. Just take a look at these. You need to know these. Okay, like 340 degrees Celsius, bitumen used for surfacing roads, whatever. And then lubricating oil, fuel oil, diesel oil, paraffin, kerosene, which is for fuels and jets, naphtha, chemical feedstock, petrol, whatever. And then petrol is the last one. And then the ones that don't condense, they go up as gases for cooking and heating. Type. So you need to know this. Okay, just go take a look at it. Read over it, please. Pause and read over it. Okay, cracking. Now we spoke about cracking a lot, so much at this point. خلاص, we talked a lot about cracking. Before we go into polymerization, let's finish this. This recording is well over almost 2 hours. A large proportion of the products of fractional distillation are long chain hydrocarbons. Okay, you need to know that a large proportion of the products here are long chain hydrocarbons. So what happens when it's a long chain hydrocarbon? What do we always do? We do cracking. We break it down because we want it to be smaller. There are two types of cracking: thermal cracking and catalytic cracking. Catalytic cracking is the one we spoke about for alkanes, and is the one that needs a catalyst, like silicon oxide, Al2 and Al2O3, right? This is the one we're familiar with. But there's now thermal cracking, which is 700 degrees Celsius and 30 atm. But basically for alkanes we use this one. Don't stress on it. It's easy. Just remember, if you raise the temperature extra, you can crack it because of the temperature. But it's happening. Focus on catalytic cracking. I don't want you to forget it. Okay, ZKD19 lists 4 fractions obtained from the fractional distillation of crude oil and state 1 common use of each. Let's open it. Okay, from crude oil, what do we get? We get refined natural gas. Okay, methane, ethane, propane, and butane. Is this the same question? Yeah, for here they give us the four: natural gas, naphtha, kerosene, and diesel oil. Okay, uh, any one of these is fine, huh? Any one of these. So natural gas, what's it used for? What's natural gas used for? Heating and cooking. Naphtha is for medicine, whatever. What? Naphtha? Chemical feedstock. Yeah, they chose the four worst ones. Yeah, they could choose other ones are better. Okay, any ones of these are correct. Okay, kerosene for jet engines and diesel oil for internal diesel engines. Whatever. Any, like I told you, any one of these are correct. Distillation normally produces large amounts of long, strong, straight chain hydrocarbons, which have limited usage. On the other hand, short branch chain hydrocarbons, which are in high demand, are normally produced in relatively low quantities. What process is used to convert the less useful ones into more useful ones? What did we do to convert the long chains to the smaller chains and make them useful? The process was cracking, right? So the answer for 20 should just be cracking. Yeah, cracking of hydrocarbons. Question 21. The following diagram shows the tower used to separate petroleum. Give the name of the process used to separate petroleum. Acid fractional distillation. Which physical property is the base for this process? According to what do we separate petroleum and fractional distillation? Obviously the boiling point. Which is the most volatile, A, B, or C? Like I told you, as you go down, volatility decreases. So if you want the most volatile one, it's all the way at the top. So A, of course, will be the most volatile. Okay, polymerization. You need to know a polymer is basically a huge molecule. When you keep on adding the same molecule again and again, it forms one big molecule called a polymer. Okay, the subunits, the small molecules they keep adding, these are what we call monomers. Okay, you need to know that there's addition and condensation. Addition polymers, it's a single product form. Basically, the same monomer n times gets you this, the polymer repeated n number of monomers. Okay, what do you need to know the difference? In addition polymers, it's a single product formed and it's the same subunit. But for condensation, you need to know that it's a joining of molecules and it produces water or hydrogen chloride, usually water. That's why it's called condensation. Huh? Okay, what do you need to know? You need to know that for addition, it's a single type of monomer only, but for condensation, it could be anything, عادي. With addition, they have to all be the same. For addition, you need to know the monomer must be unsaturated, so there must be a carbon double bond. Okay, you need to know that. It has to be, or otherwise it's not addition. طيب. For condensation, monomers must have two functional groups, which could be similar or different. Whatever. You know, basically what they're trying to say is it can be anything. It doesn't necessarily have to be carbon double bond. Polymers can also be classified into natural and synthetic. Natural are the ones in nature, and synthetic being the man-made. Define the following terms. Polymerization. Let's see. It's the process of linking relatively small and simple molecules to form large macromolecular units. Very easy. Monomer is a molecule that's linked to other identical molecules to form a polymer. صح? Name the two classes of polymers. Name the two types of polymerization process. What are the two classes of them? Synthetic and natural. And what are the type of polymerization processes? Addition and condensation. Right? Question 26. Polymers can be either synthetic or natural. What are polymers and how are they found? Okay, polymers are large molecules made from monomers, right? Let's take a look. 26. Polymers are giant macromolecules. They are formed by joining a large number of small repeating units called monomers. Monomers are joined by either breaking the double covalent bond between their carbon atoms or by eliminating some atoms in the form. Okay, how are they formed? You need to know. I'm gonna explain it, okay? قول عندك I don't know C2H4. This is ethene, okay? Let's say and I kept adding 1,000,000 ethenes. Okay, you kept on adding, Let's say you had ethene n times. Okay, instead of just keeping on adding. Let's say you had it n times. What's gonna happen? You're gonna get this C, C, H, 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 H. Okay, you have to keep these two lines outside. Okay, and basically you put a nice n. Okay, this basically shows that, okay, you're repeating this so many times, you get a macromolecule. It's huge. To do that, you must know that this double bond here has to be broken and become single. This way it allows for the carbon to hold one more hydrogen here, one more hydrogen here. Okay, which connects the other two glucoses. Other than that, it's not too hard. This is what we call addition. Okay, when you keep on adding so many of the same one, you just get this with a broken double bond and hydrogen on that. What's this called? This is called actually polyethene. You see the poly? Poly is because it's a polymer. Okay, you need to put this N to show it's a polymer. Let's continue. Okay, these are just the classes of polymers, the synthetic and natural, whatever. Okay, the only natural one is the protein, peptide or amide bond. Okay, whatever. Okay, ethene C2H4 undergoes polymerization. Draw a diagram including structural formulas to show the polymerization of ethene. I think I just drew it now before erasing it, but let's see. Question 28. This was ethene. You see, N times under heat, pressure, and catalyst to get this. I told you break the double bond, we just put an N down. Identify the monomer in the repeating unit. Okay, this is very important. You see this question a lot. What's the monomer in the repeating? The monomer in this case is going to be this. Okay, C2H4. Okay, monomer is what you started with. Repeating unit is what you're ending with. This thing here. Okay, and what's the name of the polymer? Obviously polyethylene. Okay, these are just tables for this is the table for some known polymers. Okay, like polyethylene, polypropylene, PVC polyvinyl chloride, Tefal, poly whatever, tetrafluoroethene, polystyrene. Okay, you need to know just what these are good for. Okay, just read over them. Okay, some type of plastic can be melted and used again. These ones are called thermoplastics. Other types decompose when they are heated. These are called thermostatic plastics. Recycling is different because the different types of plastics must be separated. Okay, this is important because I think one of them is thermo or something like. But they don't ask this stuff, it's hapsam. Deduce the monomer of the polymer. Okay, we have this is a polymer. Let's take a look over here. What's being repeated? I think you can see this is being repeated, right? Okay, so you just take it out and create a double bond, right? So we identify first the monomer as the repeating unit, take it out, put a double bond between it. Draw the polymer from propene, whatever. Yeah, for very basic. If they gave you this and they asked you to draw the polymer, just draw, put CH3, CH2, double bond CH2. Okay, what do? We break this. Okay, let's just draw it properly. CH3, okay, to CH2, bonded to CH2. Okay, let's make it a polymer. How do we make it a polymer? We break this bond, right? This double bond. How does it look like now? Okay, cake. And this is how it should look. And then you put an N outside. I don't know why here they only considered this small part. I don't know. But anyways, this is they're very easy. Like I told you, just break the double bond. Write an equation to show how the following compounds polymerize. Okay, let's start with C2H4. Okay, let's draw it. C2H4. H, 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 H. It polymerizes, right? What's it gonna look like? Break the double bond. What do you add when you break the double bond? It needs now 2 hydrogens. So you just put a 2 here like this, 2 dashes. Okay, and you put N. C2F4. C, C, F, 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 F. Same thing as the last one. You have to break the double bond, write all the F's, and just include 2 spaces, and write an N. Okay? And then C2H3Cl. And then C2HCCl, even though they may look weird, just draw it, man. ما بدها C2H3Cl. We know here it's carbon double bond, huh? All of these are carbon double bond. Put an arrow, it's N outside, right? Break the double bond. Extend these 2 out, and then put an N. That's it. Okay, just to recap, because I fell asleep. When you're drawing a polymer and you have a monomer, you need to remember we have 2 types, okay? What we've done until now is addition, okay? You need to remember the general rule for addition, okay? For addition, you have a carbon double bond, always. Whatever the compound is, there's always this carbon double bond, okay? So if they ask you which one is addition, you have to look at the ones where there's a carbon double bond breaking, okay? And you're ending with a carbon single bond, okay? So it should look something like this, because I remember I saw it multiple choice in one of the exams, okay? So let's say you have ethene. This is the general rule, no matter what molecule you have. So, hello, what did we have? We had, I just solved this. I'm just going to resolve it because I fell asleep, okay? C2H3Cl, okay? Draw it. Always remember, when you're drawing it, C2, they're bonded by a double bond, okay? Polymers, carbon double bond, carbon double bond, carbon double bond. Remember it, okay? C2H3Cl, okay, breaks. You break this, comes single, and what happens when you break a double bond? It opens up 2 more new bonds, okay? I'm just recapping this, okay, before I move on into condensation polymers, okay? Let these, we don't actually draw the H and H, we just draw these 2 bonds, okay? And we extend them outwards, okay? Although, yeah, it's not something you use the mark for, but it's nicer to extend it outwards to show that it's connected to the other monomer, okay? This is how it's called. This is called the monomer, and this is called the repeating unit. I just solved and my mic is working. Yeah, I just solved exercises. I'm gonna go. Are the polymers addition or condensation? Of course, they're addition. Why are they addition? Because a carbon double bond is being broken to form a single one. Okay, so let's take a look at the solution here. Question 23. They're addition polymers. Okay. Always, by the way, if you're writing this equation, if there's n here, come in, there should be n here, okay? Because this n times, that means you should have this n times as well. Okay, this n, you put it at the end to show, oh, you have this n times, and then n of this, like, مثلا, math, okay, you have this as a coefficient, okay? When you have a lot of it, you have it as a coefficient, okay? And then over here, the monomer, actually, I don't know how to say this in math terms. Anyways, just write it like this, please. Okay, this n times and this n times. So n of this, think about this. N of this, since there's so many, will get me this n times. Okay, write an equation to show how styrene polymerizes. Okay, please, by the way, I saw this once. Let me show you. It was for the, I think it was an ester, one of the esters. 1 second. Where is the ester? 1 second, oh. Yeah, so they drew this for me. CH3, CH2, double bond O, bonded to OH, bonded to O. No, sorry, no, mistake. Bonded to another O. Bonded to CH2, CH3. Okay, this is obviously, when we have this double bond OO, this is obviously an ester. اتفقنا. This is just all of it cramped into one formula. طيب, they asked, is it going to be addition or condensation polymer? What some people will do is they're going to call this an addition polymer. Why? Because they see this double bond. They say, oh man, what he told us double bond. Ma la, it has to be a carbon double bond. Okay, here, what's the double bond? CO. Okay, well, if you see this, please, this doesn't mean hydrogen carbon double bond. Okay, this means carbon carbon. Okay, don't mistake it. Okay, why does it mean carbon carbon? Because CH2. Why does it mean carbon carbon? Because it looks like this. Look. Okay, and the H is here. Okay, you'll never see a hydrogen double bonded to a carbon. Okay, it doesn't work like that. Okay, so if you see this, it's carbon with carbon. But so we don't write it like this. For practical reasons, we don't write it like this. Okay, this is wrong. You'll never see this. Okay, you're gonna see it always like this if you see a double bond. Type, anyways. Over here, write an equation to show how styrene polymerizes. Okay, styrene is one of these macromolecules over here. There's a lot. You're required to know all of them, but they're all pretty much the same thing. I'm just gonna do one, and خلاص, you should know the rest. Okay, C6H5C1CH2. Okay, what do we do? In my opinion, you should draw it. Okay, so start always with the carbon double bond. Okay, CH2, you have a HH over here. And this is bonded to what? C6H5. Okay, this is bonded to C6. Wait. Yeah. I had to check this. But you go C6H5, and then you add a hydrogen down here. Someone's gonna ask, okay, so where do you get the hydrogen from? Okay, basically what our lovely chemists do, if they wrote a H here, it's gonna look like this. Okay, فأنت just draw it. Okay, draw it. If you're in this situation, draw it. And if you feel like something's missing, because carbon should bond to two things, just throw in a hydrogen. Okay, because basically in the structural formulas, chemists choose not to write the hydrogens because that's the whole point of the structural formula. You just omit the hydrogen bonds. Okay, so just draw. If you ever feel like something's missing, just throw in a hydrogen. Okay, yeah. How do we polymerize this? Remember, we put brackets and outside. What do? Draw an arrow, break the double bond, right? And then protrude two bonds outwards and put our lovely N. That's it. Not much to know. There you go. Okay. Condensation polymers. Condensation polymers are a bit long, but كل شيء بيتفهم. Okay. Condensation, you need to know, it means water is coming out of it. Okay. How do we produce esters? Remember, we produce esters because esters are huge molecules. So polyesters. How esters are huge molecules بينحسبوا polymers. Okay, especially the bigger ones, but some are small عادي. How do you get to ester? No, it's an acid plus an alcohol, right? And what is produced? Water. So when you see that water being produced, you can consider it a condensation reaction. Okay, it's called a condensation polymer. So since our polymer is actually coming from two things, the alcohol and the carboxylic acid. So how many monomers do you have in this case? Two, right? You have two. You have the carboxylic acid and the alcohol. Let me explain what they wrote here. Okay, this square stands for R, by the way. Okay, and this other square stands for another R. Okay, we can just call it R prime. I like to denote it as R and R prime, but they use boxes, which is fine. I don't like doing it. Okay, but they call it dicarboxylic acid and diol. Why do you think you're using di? because now we need a big molecule, so you can't just have a carboxylic acid and an alcohol. Okay, that's why we have at least a dicarboxylic acid and a diol. Okay, this how do you react? Remember how does the alcohol and carboxylic acid react? These come and form a water, right? And then these two bond together, forming a C double bond O linkage, right? You see, you should know, okay, for every C double bond O, OH, and then OH, there's a linkage. So also here, by the way, as you can see this one here, okay, this will also form a linkage, as you can see here, okay? So if مثلا they asked you how many linkages are you going to have, take a look at the molecule and scan it properly. How many functional groups do you have? You have one here, one here, so that's two on the left, and come on, you have two here, so that means you're going to have two linkages. Since we're forming an ester, the linkage is actually called an ester linkage. Okay, so as you can imagine, let me just take this into, can I take this into open board? Let me see, does it work if I scan, if I select part of it? No, it doesn't. Okay, خلاص, I'll just draw it. Okay, so let's say you have the dicarboxylic acid bonded to its functional group, right? And over here bonded to its functional group OH, right? هون عندك الدايول R prime bonded to its functional group OH, هون bonded to its functional group OH. Okay, what happens? These two break off to get water, right? So this comes and pushes over here. Type. What happens as well? These two break off to get water, right? So what happens right now? We're left with this molecule. Let me just remove these. Hold up. So it looks like this. What are these called? These are called ester linkages or ester bonds. Okay? Since it's an ester, it's called an ester bond. So let's compare our structure to the one they drew here. As you can see here, R prime, C double bond O, O. Okay? Not that hard, voila. Okay, just to fix something. Actually, when taking everything out, I did it correct, but just to make sure it's perfect. Over here, when taking it out, it's preferable to take the OH out of the carboxylic acid. Okay? And then only the hydrogens out of the alcohol. Okay, and then smushing them together, because apparently she prefers it to be like this. Okay, so it should look like this. If you look at the product, she kept the oxygen over here at the end. Okay, which is عادي يعني, it's the same thing almost, but you need to do it like this. Since my teacher came in, she told me this. Okay, you're gonna write it like this. Okay, and okay, and it shouldn't be protruding outwards, this thing. Okay, keep it عادي. Okay, it's just like this. And what's produced as well? How many water molecules do we have for each di and di? H2O, we have how many? 2, right? So since we have this n times, this should also be n times. Not that hard. Okay, polyesters, PET stands for polyesters, okay, can be converted back into monomers and repolymerized. So in case they ask it, it's the most commonly used polymer in the world, found in many types of packaging for food and drink, clothing, fibers, and bottle production. Polyesters is one of the most used polymers. It's used in packaging, foods, and beverages. What are the monomers involved in the polymerization? What is involved in polyesters? We said the dicarboxylic acid and the diol. What CQD is this? 29. Let's go to 29. Diol and dicarboxylic acid. Draw the structure of a PET polymer. We just drew one here, so you can just copy it. Okay, but if you want, it starts with the R bonded to its C double bond O, O bonded to the other R prime, bonded to the O, right? Bonded here to the C, double bond O. That's how it looks. And you put this n times, right? So let's take a look at the solution. CR bond C double bond O. Oof. Why? She drew 2 units? Yeah, she drew 2 units. You can keep them protruding outwards, huh? Put the bonds outwards. Why'd she draw 2? I don't know. But if you draw this much and put n, that should be enough. Okay. Yeah, حتى in class we drew it like this. This is fine. Okay. You can continue it, but it's fine to do it that way. Identify the type of linkage formed. If it's a polyester, what's the type of linkage? Obviously an ester linkage. Okay, and if they ask you what does the ester bond look like, this is the ester bond, right? What's the characteristic of a PET polymer? It can be converted back into monomers and repolymerized. Okay, this is one of the things you should know about the PETs. Okay, copolymers. Let me see. I'm saying copolymers like it's new. We've been doing copolymers the whole time, by the way. This is a copolymer, PET, polyesters, because it's made out of dicarboxylic acid and diol. 2 things means it's a copolymer. Okay. By the way, please read over the notes. Just look at these in case they ask them. What is dacron? What is styrene? It's a PET. Okay. Nylon, it's a copolymer as well. It's also formed by condensation because it releases water. What do you need to know about all of the copolymers? You just need to know what makes it up, okay? Again, dicarboxylic acid, اتفقنا, okay? Plus what in this case? A diamine group, okay? Amine, what does amine? For those who do biology, it kind of reminds you of amino. You guys know the amino group is NH3, but here it's NH2, okay? Amine is NH2. طيب, those who do chemistry remember ammonia. Ammonia is NH3, but amine is just it's like the stupid brother of NH3, so it's just NH2. Okay, so let's see. Dicarboxylic acid, اتفقنا, it's R bonded to 2 functional groups because it's di. Okay, and then diamine is just the R prime bonded to 2 functional groups, so 2 NH2 functional groups. Okay, what's gonna happen? Same exact thing that we did with the ester. You take out the OHs from the carboxylic acid, and from the other thing you just take out the hydrogens. Okay, let me show you. You just take these out, take these out, take this out, take this out, and you're gonna get the polymer. Let me take it into open board so that you can kind of see it properly. Okay, over here. So let me draw the R bonded to C, double bond O, bonded to OH, bonded to C, double bond OH. Okay, and then here you have the diamine. It's R prime bonded to NHH, R prime bonded to NHH. طيب شو اتفقنا? We take out the OH from the sides over here, and then take out the hydrogens from the other molecules over here. There you go, you produce 2 waters, by the way. Okay, and then take this in. So your polymer is gonna look like this. And how many times does it repeat? Remember, extend the bonds, huh? N times. So this is the polymer, but you can't forget the water, so plus 2 water also N times. Okay, so let's take a look. As you can see, bonded to C double bond O, and then C double bond O and H. This is called an amide linkage. Okay, as you can see, it's an amide linkage. C double bond O and H, amide. Okay, you must memorize that. Okay, first produced as a solid, nylon is then melted, then extruded through small holes to form fibers. The fibers are then stretched so the polymer molecules align and the long filaments are then dried. Once dry, the fibers are woven, used in the clothing industry, whatever. Nylon can also be molded into strong durable items like gear wheels. Okay, deduce the monomer from the formula of the polymer. Deduce the monomer of the polymer given below. Let's take a look here. If they ever ask you to find the monomer, she gave us the steps. The first thing is identify the linkages between the monomer unit and draw lines through. So what are the linkages we have here? You can see C double bond OO, right? We're familiar with this, right? So how do you break it up? Just split it up, right? Let's take only 2 repeating units. Let's just take this, or just split all of them, just so you can kind of get what's going on, right? So this is C double bond O, C double bond O. I'm just gonna follow what she did, okay? So she identified the linkages, كلهم C double bond O. She broke them, okay? And when you break them, just take it to the side. You have now a C double bond O, a C double bond O, okay? Redraw the monomers, adding an H to the O end and an OH to the C double bond O end, always, okay? So this one also you can't forget now. Okay, you took this monomer out, but you can't forget this one as well, okay? If it's an O, you just add a hydrogen. If it's a C, you have to add OH, okay? Just like that. Okay, draw the addition polymer from its monomer, whatever. Identify the functional group, we did this already. We did this, خلصنا already. Yeah, this is the repeating unit. We did this, right? This is one repeating unit. If they ask you to draw 2 repeating units, you basically just draw this and copy everything one more time. Okay, so you'd copy it, the bond, this N, you'd bond it to C double bond O R, C double bond O N H R prime N H. Okay, let me just show you if they asked that. Okay, if we ask 2 repeating units, because I remember in one of the questions she asked it in the past papers. Let me just think, can I copy? What is copy? Yeah, okay, perfect. Okay, just like that. Okay, this is 2 repeating units. Just like that. Okay, you literally all I just had to do was copy paste. Continuing, they're just talking about, I explained all this right now. 3 repeating units, again, just copy it again. Okay, comparison, you need to know the comparison between the addition and condensation. Obviously, you need to know that in condensation, water is produced, okay? Addition, nothing is produced. In addition, you only have one monomer, right? Let's go through them one by one. In addition, usually it's one unsaturated monomer, right? Remember, for addition to happen, it has to be carbon double bond. Remember this, please, okay? Condensation, it's 2 monomers with at least 2 functional groups per molecule, right? You need to have 2 different functional groups for condensation. So to know condensation, it's basically 2 different molecules adding together. Reaction type, monomers joined together with double bond opening up in an addition reaction, right? Remember, we break down the double carbon bond. In condensation, every time 2 molecules join, a small molecule is lost, and usually what is that small molecule? Water. Product properties, obviously it's a single product. In condensation, you have 2 products. Remember, you have the actual molecule itself, the repeating unit, as well as the molecule lost, which is usually water. Non-biodegradable, but you should know condensation can be biodegradable, okay? She can ask any of these. Addition is resistant to acid-base, can be hydrolyzed back to monomers if heated in acid-base. Like PET, remember? Polyesters, remember, we can hydrolyze it back to monomers. Remember we said PET, you can change back to monomer. Okay, you have the main difference between addition and condensation. We just wrote it here. So she's definitely going to ask this. Okay, addition, double covalent bond is broken. In condensation, the atoms are eliminated to form a byproduct, right? Here, addition, all atoms are found in the polymer, but in condensation, some are lost as the byproduct. Whatever. These as well, in case she asks. Okay, advantages of plastics, whatever. Light, of course, is extremely strong, cheap, resistant to corrosion, low conductivity. Okay, memorize it. Disadvantages, it's very difficult to dispose of, so they're buried in landfills, they accumulate in oceans. Most are non-biodegradable. Okay, you need to know that. Okay, she put it in bold comment. If she asks it, you'll see why. Burning plastics produces toxic gases such as hydrogen cyanide. It's difficult to recycle. Okay, pretty straightforward. Measures to reduce impact on environment, reduce plastic packaging, oh my god, reduce single-use plastics, reuse, okay, whatever. Consider the following 2 monomers, okay? Represent the structure of the polymer that can be produced when the monomers react together. Don't panic, just draw it. Yalla, C2H4, okay? Let's see. Please don't think this is a carbon double bond, If it was a carbon double bond, it would be written for you, okay? Unless it's just C2H4 and this is the molecule. Of course, she's not gonna write it for you, okay? Let's see, C2H4, so start with your carbons always. Please always start by drawing your carbons, okay? It makes your life way easier. Okay, and the K, OH, and the cone OH, okay, plus we have, what's this, COH, so this is C, double bond O, OH, remember, COOH looks like this, huh? Don't just write it as COOH, no, this is how COH looks. Okay, C6H4, I'm just gonna write C6H4, huh? I'm not gonna write it all. Bonded to, again, COH, so C double bond O, OH. Type, what do we do? As you can tell, what we have right now is, what's OH? That's an alcohol, right? And just so you can understand what's going on. And what's this OOH? Isn't that a carboxylic acid? Yes. Okay, what do we do? What's our general rule? We always take out the OH from the acid, right? And we take out the hydrogens from the alcohol. So what's it gonna look like? Heck. Okay, take this out. Over here, take this out. I wish I had the select feature here as well. It's okay. Anyway, yeah, okay. So let me just copy this all here. C double bond O, C6H4, C double bond O. Okay, and that's it, yeah, pretty much it. Okay, and extend the bond. Okay, so I'm looking at the answer key. They did it a different way. They drew it as radicals, which is smart. I'm gonna redo it as radicals. Okay, even though this is correct, but usually when you have big molecules like this, just call this R and R prime. Okay, and by the way, it's easier to have the acid first. Okay, if I have the acid first. Okay, if you ever see it like this, even though it's not wrong, anyway, it's not wrong, but please, it's better for you, makes your life easier if you have the acid first, because نحنا, the way we learned it, the way I explained to you, it was always the acid plus the alcohol, مش alcohol plus acid. Okay, عادي, it's okay يعني. Okay, C double bond O, OH, right? Plus this, we're gonna call it R prime, bonded to OH. Okay, bonded to OH. Right? What do? We take this out, we take this out, we take this out, and we take this out. So let me copy it down here. You're gonna be left with R bonded to C, bonded to whatever here, double bond O. Okay, bonded to C, double bond O. Smush this together, you're gonna get bonded to an O here, bonded to R prime, bonded to O. Okay, and just extend the bond outwards, and you're gonna get N plus, obviously, they only asked for the polymer, so you don't need to mention the water. Okay, if it looks like this, see, what are they doing here? And I don't know why. Okay, yeah, it's the same thing, but then they just swapped. They did it with alcohol first. Again, guys, it doesn't matter, huh? But this makes it easier for you, trust me. Okay, when you have acid plus alcohol first, it doesn't matter, whatever you prefer. You can use they said you can use X and Y to represent certain groups of atoms. Okay, if they said this, then you have to use X and then Y. Even you don't have to, you can. Is the polymer produced an addition or a condensation? What do you think? If you have two monomers, then it's a condensation, right? Is the polymer produced circle the ester group in the polymer? Okay, in the polymer, what's the ester group? This, right? And this, we have two ester groups. So I don't know why they didn't circle this one. No. I think I know why they didn't circle it. Because it should be between both radicals, between both R groups. Sorry. Okay. So if you were to choose between one, okay, circle the one between both R groups. Okay. Okay, they're done here. Question 25. The structure of nylon can be represented as such. Okay, is nylon addition or condensation? What do we know about nylon? Nylon was If I'm not wrong, it's the carboxylic acid. Remember, I told you carboxylic acid plus diamine, right? Diamine, yeah. Is it addition or condensation? أكيد it's condensation. Okay, circle the amide bond with peptide linkage in the above structure. I told you it's this. This is it. Usually the thing connecting both R groups, that's usually whatever linkage they're looking for, it's usually the one between both R groups. Okay, draw the structures of the monomers from which nylon is produced. أكيد it's gonna be what I told you, carboxylic acid and diamine. We have to use the boxes since they used it in the question. You have to use box. We're gonna use shaded box for let's take a look here. Wait. The shaded box is for the carboxylic acid, because obviously this one's the one connected to the nitrogen, so this is the diamine. Okay, how does it look? It's bonded to C double bond O, OH, and then here it's bonded to C double bond O, OH, as usual. And then this one here is bonded to, I told you, NH2, H2, and H2, H2. If you forgot, go back to when I explained the amides here. Okay. We only have one more, so we're almost done actually. One more concept. Okay. They actually wanted you to. Okay, we got this. So we used boxes, which is fine, by the way, that should be fine. If they said the box and box represents, then that's completely fine. But they want to know. Okay, does she want you to know how to name it? Okay, just skip the naming. I don't think you need this. Okay, out of everything, it shouldn't come. But like, I don't get this one, but I get this one. Why? Because it's obviously 6 carbons, with 2 aminos, so diamino hexane, بس 1 to 6. I'm not gonna do it. خلاص. I don't think you need this. Natural macromolecules, proteins, natural polyamides. Okay, you need to know the proteins. Okay, very fast. If you've done bio, by the way, especially AS, for the maybe 15 students in all of grade 11 who take it. But basically, proteins come from one monomer. It's called an amino acid. You need to know it's a natural macromolecule. Okay, how does it work? Basically, an amino acid looks like this. Okay, actually it should be the C down and H up, but I don't know why they drew it like this. So basically, what happens here for proteins? I'm gonna take it here, use my biology knowledge that I learned before dropping. Basically, a protein is made out of amino acids. Why is my APC lagging? Okay, open board, it's not working for me. Okay, it's made out of amino acids. My PC is lagging a lot. I'm getting 30 FPS on open board. I don't know how cooked that is. Yeah, it's just amino acids being repeated. What does an amino acid look like if it came for you? It looks like this. Okay, over here it's an R group bonded to C and H. Okay, bonded to the amino group. Okay, which looks like this, like the same amino group we used for the amides here for the diamine. Okay, bonded to a carboxylic acid group. Okay, type. What happens? It's basically amino acids being repeated. So when it comes into contact with another amino acid, which looks like this, I'm just gonna copy it. Okay, duplicate, take it here. Okay, let me remove this. What happens here? Same thing as last time. You take this out, take this out. Okay, what happens? They come out. Oh shit. They come out, right, like this. This comes out, goes out. Okay, what happens? These smush together and you get this. Okay, over here, can I rotate this? Okay, I'm doing too much والله. Okay, but anyway, it looks like this. And what linkage is this? Isn't it the same that we discussed earlier? The amide linkage. Okay. Other people call it what? Peptide bond. Okay, if you're a biology nerd. Um, that's pretty much it. You just have it repeating. You have the R group that repeats itself. But the R group is very simple. It's not hard. But for the sake of chemistry, put the R group on the side with the carbon in the middle. Okay? Just do it like this. Oh, we take this here. Okay. طيب. So if you want to draw the polymer, you have to do this, right? And put N, right? Okay, protrude it like this. Type. And again, water is released, for every amino acid. For every one you add. Type. How do you hydrolyze? Hydrolysis basically means breaking down. How do you break down proteins? Just boil them. I'm sure you guys know, anybody who has done year 1 bio knows that protein can be denatured if you boil it, right? So boil protein in acid or mix it with an enzyme, and basically the protein will break back down to amino acids. How can you separate it? If they ask these, and these are all potential questions, how can you separate and identify amino acids present in a protein? Protein is hydrolyzed in the presence of dilute HCl into amino acids, right? So when you put it in HCl, it's into amino acids. And then how do you identify those amino acids? Remember chromatography, when you put a locating agent, right? Spraying the chromatogram with a suitable locating agent to find the amino acids, or measuring the RF value and compare the results to that level. Type. So you spray it and then measure the RF value. Type. Anyways, these are just extra questions. There are some questions that weren't in the notes but were in the material, so I'm gonna go do them now. Okay, in the notes, none of the top questions are there, so we're gonna go through them right now. All the tops, 31 to 38. Okay, فنحنا in the notes I did for you these were all in the notes. Okay, but these now we're gonna do in the course revision. What's the type of polymer shown below and how is it formed? طب let's take a look at it really quick. Okay, we have this is the R group, okay, bonded to NH. Okay, let's take a look always. When you want to identify it, look at the functional group. Functional group over here is C double bond O bonded to an NH, right? Okay, so we could say this is a what linkage is this? It's called an amide linkage, right? We just went over it. The C double bond O NH. Okay, guys, if you want to memorize the linkages, okay, please do. Okay, C double bond O OH. This is ester linkage. Okay, and what's it called over here? It's C double bond O NH. Please know this is an amide linkage. Okay, please know these two, amide, or other people call peptide. Okay, type. So over here, which one are we going to choose? It's an amide, in other words polypeptide. And do we get it by addition or condensation? Remember, addition is just one monomer, condensation is 2 or more. Over here when we did it, was it 1 or 2? Obviously it was 2. 2, or wait, is it 2? It's gonna be addition. Why is it addition? And I just thought about it, because this, remember we did proteins and we did the nylon, this one. Okay, which one? How do you know which one is which? Over here the R groups are in the middle, عادي, they're bonded. Over here the R groups are on the side chains. Okay, so since you have the R on the side chains, what are we referring to? We're talking about the proteins. And remember, what did I tell you about the proteins and amino acids? It's a natural polymer and it forms by addition. Okay, it's formed by addition. So the answer should be C. Question 31. D. Ah, shit, my bad. Yeah, basically, okay. It is D. Why is it D? It's D because I think I know why. It's because of the condensation. You have a byproduct formed. Okay, in addition, you only have one product formed. Okay, remember نحنا, okay, although we're using the same repeating subunit, okay, we're forming water each time, so that's why it's considered condensation polymer. Okay, sorry, huh? بس خلاص, I think you'll remember it. Oh, what, I made a mistake on this question, you should remember it. Okay, so it's a polypeptide formed by condensation for the proteins. How do you know it's a protein? Because of this R side chain. Always when you get a type of question like this to identify it, look at the linkage. Okay, amide. Okay, which one was amide linkage? We had two, the protein and the nylon. Which one is it? They're both they're both condensation. But how do you know which is which? Take a look at the side chain. The R is on the side, and that we don't have that for any molecule except for amino acids that we studied at our level. What is the products of thermal decomposition of an alkane in the absence of air? In the absence of air. Look, you have no clue. First, take a look at the answer. B, alkene and hydrogen gas. Okay, makes sense. I think they're referring to cracking. What did we say thermal decomposition of an alkane was? Let's go back to our notes. Over here, I think it was page 6-ish. Okay, bad. Alkanes, thermal decomposition, let me find it. Yeah, over here, the decomposition at high temperatures, and you get an alkene and smaller alkanes, and it wasn't in the notes, but sometimes you get hydrogen gas. Okay, I mentioned it when I explained it. Sometimes you get hydrogen gas. Okay, none of these have alkane in it, so that's why you can just skip it. And what we care about in cracking is alkene and hydrogen gas. Okay, the structural formula of an ester is given below. Which of the following represents the formation reaction of ester E? Let's take a look. What? This is ester E. Okay, the formation reaction of ester E. Type. Let's take a look. What's happening here? Ester, you guys know, it's a carboxylic acid plus an alcohol. صح? Type. Let's take a look. Which one added to which one? Over here, we have only one hydrogen. Okay? So, you could say this is HCO3. Yeah. Sorry, ما خص hydrogen. I don't know why I'm mentioning hydrogen. You only have one carbon. Okay? So, what type of acid is it? It's methanoic acid. Methanoic acid. طب here you have two carbons. So, what type of alcohol is it? Ethanol. Right? طيب, okay, but we have two with methanoic acid plus ethanol. What are the products we get? طيب, what's the name of the ester? Remember, for the ester, it's something L plus something O8, right? The YL, we get it from the alcohol, right? I always told you, the YL, you get it from the alcohol. What's the alcohol here? Ethyl, and then the O8, you get it from the acid, so methanoate. So ethyl methanoate. So we pick D, okay? Question 34. Ethanol is an organic. Oh my god. Stop. What's this? It's 3 questions. هالقد. Question 34. Ethanol is an organic compound used in many industries. To which homologous series does ethanol belong? Obviously, ethanol belongs to the alcohol series, right? Very easy. Okay, draw the structural formula of ethanol in circular functional group. Let's draw it. You guys know ethanol, it's C2H5OH. Using the formula of alcohols. Alcohols are CN, H2N plus 1, OH, right? And Eth means 2 carbons, right? So just plug in carbon number 2. Yeah. So what do we need to do? Draw it. Let's draw it. There's no double bonds. First, we're going to draw C2H5OH. We have the OH at the end, right? And you have the hydrogens bonded like this. Okay, that's it. Circle is functional group. This is the functional group. That's it. Okay, please, by the way, when drawing any molecule, start by drawing your carbons. Okay, let me do it one more time. Carbons, you draw them together. Okay, hydrogens, you fill them out. Okay, and then at the end you put your OH. This is your functional group. Okay, so let's take a look. There you go. Ethanol can be produced by the fermentation of glucose And circle was what? No, C6H12O6 under certain conditions. Write the chemical equation of the reaction that occurs. Remember, fermentation, how was it? It's glucose being broken down, okay, to produce ethanol and carbon dioxide, right? CO2. And then if you balance it, you'll مانيش خلق صراحة. I think it's 2 and 2. And then you get 2 here, 4 here, 6. Yeah, it's balanced. It's 2 and 2. Type. Yeah. Okay. That's the reaction. خلاص. Ethanol breaks down into, as the glucose breaks down into ethanol. Very easy. You just need to remember that carbon dioxide is produced as a byproduct. Okay. Give 3 conditions that favor the fermentation of glucose. What do you need to happen? First is no oxygen, so absence of oxygen. 2 is the presence of yeasts. And 3 is room temperature. Right? Let's take a look. Temperature, room temperature 37 degrees Celsius, catalyst yeast, anaerobic medium. If you see anaerobic medium, it means no oxygen. Okay? Glucose is aqueous. Okay, whatever. Yeah, that's bullshit. C, ethanol can also be produced by the hydration of ethene, as shown. Name a substance that can be used to speed up the above reaction. Hydration of ethene, I think it was H2SO4. Yeah, oh no, it's phosphoric acid. But H2SO4 works. But remember, I told you the one they always look for hydration, it's H3PO4. Okay? It's H3PO4 at 500 degrees, or I forgot how much. But they asked for the substance only. How much was it? Let's take a look. It was over here. Alkenes, hydration. It was H3PO4 at 300 degrees Celsius and 70 atm. Go through the notes if you want and look through all the conditions, okay? Please, because they will definitely come. So name a substance that can be used. It's H3PO4. They didn't ask for the chemical formula. They said name it. What's it called? Phosphoric acid. Okay, phosphoric acid. Okay, and it has to be concentrated. Say concentrated phosphoric acid. Okay. Where am I? Name an oxidizing agent. Oh no, ethanoic acid is a carboxylic acid that can be prepared by the oxidation of ethanol. Name an oxidizing agent using the above reaction. What can you use? You can use, remember, KMNO4. Okay. Or you can use K2CR2O7. What's the names of each one? KMNO4 is potassium permanganate. KMNO4. No, it's I don't know what's it called actually. I forgot. Manganate. Okay. Yeah. Okay. What do they call it here? 1 second. I don't think they named them over here. Potassium permanganate or potassium dichromate. Okay, you can say any of these. Okay. But they said the ions, which is completely fine as well. You can say manganate ions or dichromate ions. Okay. If it was an IGCSE, I think that's what they're looking for. Manganate ions or dichromate ions. Okay, a student adds... let me read this. Before I go to II, I think it's better for you... No, but if you write it in school, you write KMNO4, it shouldn't be wrong. Or... but you have to name it out. If you write KMNO4 in Bella, it will be wrong. You have to name it. Potassium permanganate. And if you wrote K2CR2O7, you should write potassium dichromate. Okay. A student adds 30 milliliters of ethanoic acid, so an acid, to calcium carbonate. What happens when you add acid plus metal carbonate? Obviously, effervescence, right? Effervescence. Why? Because carbon dioxide is being released, right? Metal plus acid plus metal carbonate gets you carbon dioxide gas. So formation of bubbles / effervescence. The student repeats the same experiment using 0.5 molar solution of hydrochloric acid. Compare the observations of the two experiments and explain the difference. Obviously, it's gonna be more vigorous, right, or faster reaction with HCl. Why? Because obviously you guys know all these carboxylic acids are weak acids, and you guys know HCl is very strong. Okay, so if you were to compare the difference, HCl is a stronger acid. Okay, so the observation will be it's a faster reaction because HCl is stronger than ethanoic acid. When an alcohol reacts with the carboxylic acid, an ester and water are produced. We know this. Write the structural formula of the ester produced by the reaction. What? Between ethanoic acid and butanol. I was looking for that. I'm gonna call this the R group, okay, and I'm gonna call this R prime, okay, because Sarah it's too much. Okay, so it's R prime bonded to C double bond O, OH, plus this R bonded to OH. مظبوط. طيب what happens? I told you this goes out. Let me draw it here. Okay, and this hydrogen goes out. So what do you get? R prime bonded to C double bond O, bonded to O, bonded to R, and you have water going out. Okay, how is it gonna look like? Oh, they actually drew it all. Yeah, I ain't doing all that. Okay, if in the exam, if you just say R prime and R, that should be correct. Okay, but you have to state what R is. Okay, put a nice note on the side. R is CH3. Okay, and R prime is C4H9 or what, something like this. You have to state this. Okay, otherwise it will be wrong. Name the ester formed. How do you name an ester? I told you it's something YL and then something O8, right? The YL comes from the alcohol, so here's going to be butyl, and then the O8 comes from the acid, so ethanoate. So butyl ethanoate, is that correct? Yes. Okay, is this question done? Okay, good. Methanol, ethanol, and propan 1-ol belong to the same homologous series. What's the name of the homologous series? Obviously alcohols, right? What is the general chemical formula for this homologous series? CnH2n plus 1 OH, right? Don't write this. No, don't. What is the functional group? And it's correct, but don't. What is the functional group of this homologous series? Obviously, OH, right? Ethanol can be used as a fuel. Okay, write a chemical equation for the complete combustion of ethanol. Ethanol, C2H5OH. I explained how you get it. Just plug in. F means plug in NS2. Okay, or 2 carbons. Okay, ethanol, C2H5OH. Complete combustion, right? So that means it reacts with oxygen. Combustions, you're always reacting with oxygen. But what's the difference? In a complete combustion, you produce carbon dioxide. But for incomplete, you produce carbon monoxide. Okay, and obviously water. And then balance it. You're gonna get 2 here, and like 2 have 6 here, from top 3 here. This is 4, 7 over 2. Okay, oh no, 7 over 2. You have 4 plus 3, 7. You have 1 here, so you put 7 minus 1, 6, and you need 6. So 3 times 2 gets you 6. Oh, it's just balancing, huh? Yeah, okay. Name, where am I? Ethanol can be prepared from ethene, right? Name the process and the reagent necessary to convert ethene to ethanol. Ethene, remember, C2H4. I'm telling you always, if you forget it in the exam, how to get an alcohol from an alkene, just write them both down and compare them. What do you need? You need H2O. So I need to add H2O to C2H4. So what is that called when you're adding water? Hydration. So it's called hydration. And the reagent necessary is what? Phosphoric acid. They said name it, huh? So don't write H3PO4, phosphoric acid. Okay, let's take a look. Hydration in the presence of a strong acid. Say phosphoric acid, that will be definitely correct. Okay, write the chemical equation of the preparation of ethanol from ethene. Same thing, okay? So C2H4, we're adding water to it. Okay, to produce C2H5OH. Not that hard. Okay, I don't get. Maybe they want state symbols. Do they want state symbols? No, they don't. Okay, but okay, here's what's important. Here you have to write H3PO4. Okay, why? Because whenever you have a reaction that can only take place in certain catalytic conditions, مثلا the chlorination of an alkane can only take place in UV light. So you have to write U on this long arrow. You have to write UV light. Here it can only take place in H3PO4. For on this long arrow, you have to write H3PO4. Okay, to show that this can only take place in the presence of H3PO4. Okay. Ethanol can be prepared from the fermentation of simple sugars. Simple sugars are from the hydrolysis of carbohydrate polymers. What is hydrolysis? Hydrolysis is the breakdown of a certain molecule. Yeah, that's it. Okay? But you need to react it with water. You can't just break something down by sake. You need to react with water. Hydro, remember, hydro comes from water. Okay? The word hydro. Okay? So hydrolysis is the breakdown of a certain molecule in the presence of water. State the conditions necessary for the hydrolysis of carbohydrates. I know we didn't take this. It's okay. Forget this. This is bio. The polymerization reaction of a simple sugar to form a carbohydrate, skip II, is shown in the following diagram. Complete the polymerization reaction. What do they want me to write? So they want here of a simple sugar to form a carbohydrate. Okay. I I don't get it صراحة. I think maybe water is an answer. Let's see. I don't get what they're doing. This is the arrow. Oh, okay. So here they want the monomer, and then okay. Here I get it. Okay, I didn't get the arrow. Okay, before the arrow, basically they're asking what's the monomer. Okay, let's take a look. What's our repeating unit here? Okay, this was one of the things we did in the notes. If you want to draw the monomer, you first take a look at the bonds. Okay, every bond here is, you can see what's repeating. This is your repeating unit, right? What do? You just copy that over. Okay, hold up. Is it 2 or 1? How do they do it? Yeah, okay, it's like this. Okay, take a repeating unit. Don't take the one on the end, okay, because it's not nice. Take this one, because if you take the one on the end, then you're gonna be stuck. Oh, what do I add here? Okay, take one where it's obvious, like this here. It has both ends satisfied. So if I took this here, I'm gonna have O on the right, but what am I gonna fill in here? You don't know. Okay, if I take this O over here. Okay, طيب نحن شو اتفقنا in the notes? What did we say? If you have O at the end, you can't just leave it. Okay, we took out the repeating unit, but you need to add what? Your H's, right? Okay, and what's produced as a byproduct? H2O. Okay, NH2O, I forgot. Sorry, H2O, NH2O. So NHOOH to produce NH2O. Okay, always if you have a byproduct that we know, it's water. Okay, just put NH2O if you see this. Okay, always always take it as a rule خلاص, because we haven't studied anything where something other than water is a byproduct. So NHOOH, I told you why. You take your repeating unit, you identify it. Okay, identify your repeating unit over here. Okay, take it here and just fill it in. If it's an O, you just add H's. طيب. بعد في paper chromatography can be used to identify simple sugars. What is the function of locating reagent in separating simple sugars by chromatography? I'm just gonna show you the solution because I have no idea. Okay, the locating agent, it reacts with colorless simple sugars to form color product easy to detect. Okay, it's called a locating agent, so obviously it's gonna help you locate it, right? So it reacts with simple sugars to form colored products that you can see easily to detect. If this is probably going to come multiple choice, I don't think it will come written. If it were to come, a student investigated a mixture of simple sugars A, B, and C by chromatography and got the following chromatogram. Let's take a look. Calculate the value of RF for sugar A. Sugar A, okay, 6 divided by 10. It's not that hard. 0.6. Remember, it's the distance traveled by A divided by the whole solvent. So 6 divided by 10. It is not possible to identify sugars B and C using paper chromatography. Explain why. I don't know why. They have similar RF. Okay, makes sense, yeah. 36. The structures of 4 organic compounds R, S, T, and W are shown below. Hydrocarbons can be classified into saturated and unsaturated. Which of the following is a saturated hydrocarbon? Saturated means there's no carbon double bond. Let's take a look. Which one doesn't have no carbon double bond? R and W, right? Let's see, R and W. Is it R and why not W? It should be W as well. I'm even asking the AI. I think it's a mistake in the course revision. It should be W because there's no carbon double bond. So it should be R and W. What is a saturated hydrocarbon? A saturated hydrocarbon is one that does not contain a carbon double bond. Okay, has only single bond. Yeah, okay, you're proving yourself wrong. I don't understand. It should be R and W. Okay, compound S and T, you guys get this, because there's, what is saturated means there's only single bond between the carbons. Okay, compound S and T belongs to the same homologous series. Okay, to what homologous series do they belong? Let's take a look. Carbon double bonds, without even asking yourself, from our knowledge at our level, the only one with carbon double bonds is alkene. Okay, alkenes. And did they ask for the general formula? Yes, CnH2n. A student adds bromine water to compound T. Okay, what happens to bromine water when you add it to an alkene? Remember, it decolorizes, right? So change of color, right? Decolorizes. It was bromylation of an alkene. Remember, we did it. It was in the notes, So when you add bromine or fluorine or chlorine, specifically bromine, to an alkene, it decolorizes even in the dark. The above reaction is accompanied by a visual evidence. This enables bromine to be used as a test for the presence of compounds of the same family as compound T. What is the visual evidence? No, isn't it just decolorization? No, part I was what type of reaction. Okay, what type of reaction? Okay, it's addition. Bromination is an addition reaction, right? And then what is the observation was the decolorization. Okay, I didn't see it, I skipped part I. Draw the structural formula of the compound produced by the reaction between compound T and bromine and name it. Show all of the atoms and all of the bonds. Okay, very easy. Basically what happens, this breaks, right? So what happens when this breaks? You now have CH bonded to Br, okay, bonded to CH2. Is it CH2? CH2? Yeah, bonded to a Br. That's it. Yeah, خلاص, you broke it, you add 2 Brs now. It's not that hard. But they want us to draw it fully. Let's draw it fully. Okay, CH3, CH2. How do you draw it? C bonded to 3 hydrogens. Bonded to C. Bonded to 1 hydrogen here. Remember, we broke the double bond, but now it's single. So hydrogen, hydrogen. Okay, you now have space for the bromines here, no? That's pretty much it. Okay, this is the same as this. Over here, name it. What is this? Okay, to name it, it's I think dibromo. What was this? Was propene? So dibromopropene, I think. Yeah, dibromopropane. Okay. Yeah, I told you when you do bromination, chlorination, or fluorination with an alkene, when you want to name it, as usual, you take your longest chain, okay, and what is it? It's 3 carbons on our longest chain, right? So what is it? Propane. Since there's no more carbon double bond, I can't call it an alkene anymore. Can't say propene. Okay, so propane. Okay, and where's the branches? If you start counting from the left, it's on 2 and 3. If you start counting from the right, it's on 1 and 2. So 1 and 2, so 1, 2, dibromo, dibromo. Why? 1, 2, okay? And why is it di? Because you have 2, okay? And bromopropane, okay? Okay, then what did they say? Compound R reacts with chlorine under certain conditions. R, to find out an alkane, right? State a condition necessary for the reaction to occur. What happens to alkane and chlorine? You need to be in sunlight or UV light, right? I told you. What's the type of this reaction? Is it addition or substitution? Substitution. Why? Explain. Why is it substitution? Because you swap. Yeah, the chlorine replaces the hydrogen, right? The following polymer. Remember, the only substitutions is the one. Ya Allah. The only substitution is when you have an alkane with chlorination or bromination or fluorination. The following polymer is formed from polymerization of one of the organic compounds R, S, T, or W. Identify which of the following compound, which of R, S, T, or W is the monomer for this given polymer. I told you, when you want to find the monomer, identify the repeating unit. What's repeating? You have HCH3, HCH3. Okay, so let's take this. Okay, we're going to take this. What do? We're going to take it to the side. We're going to continue it like this. Okay, and extend our bonds like this. Type. What is this? You have to put a double bond now. You're gonna ask me why. Look, isn't it the same repeating unit again and again and again and again and again and again and again? Right? It's the same thing. If you look at this, if you kept it like this, okay, let's say you kept it as single. Okay, you're left with what? CH. How do you write this? CH3. How do you write this? Yeah, for which one has, if let's say you kept it single, look at which one here has CH3. Which one has 3 carbons أصلا من الأصول? This is the only one. Okay, so T. Name the monomer. What is the monomer? اتفقنا إنه T is the monomer, right? We said T is the monomer, right? So the T is the monomer because it's the only one with 3 carbons. Type. How do we name this? What is this? This is 3 carbons. It's obviously an alkene, right? We said this is an alkene also from the start. Okay, how do we name it? So it's just propene, right? Because it's 3 carbons and it's part of the alkene family. It's just propene and there's no branches, so nothing too fancy. propene. So what's the polymer gonna be called? Anytime you want to name a polymer, you just add poly. So it's gonna be polypropene, to show that it's a huge repeating units. Type F. One of the given compounds reacts with a carboxylic acid to form the ester ethyl propanoate. Let's see here. They want us to identify which one reacts with the carboxylic acid to produce the above ester. طيب, these are all أول شيء before continuing, carboxylic, how do you get an ester? It's carboxylic acid plus alcohol, right? Type over here, which one's an alcohol from our 4 compounds? Which one has an OH group? W. Okay, for the only one is W. And which name the compound W? Subhanallah. They said W after it. Name compound W. What is this? It's an alcohol. How many carbons does it have? 2. So it's going to be ethanol, right? That's it. Let's take a look. Continue. Name the carboxylic acid. Type. Okay. Ethyl propanoate. Okay. By the way, if you didn't know, just look. Remember that the YL comes from the alcohol, so it's obviously ethanol. Name the carboxylic acid. What carboxylic acid are we going to use? Remember, the YL comes from the alcohol. The carboxylic acid comes from the O8, so it's going to be propan. So what's the carboxylic acid? Propanoic acid. Okay, let's take a look. Propanoic acid. Type. They say draw the structure of ethyl propanoate. Show all bonds and atoms in the structure. If you don't know how to do it, remember, esters look like this, right? They have R bonded to C, double bond O, and then R prime, right? Remember, the functional group of the ester is this C double bond O. How do we do it if you don't know? Yalla, you have ethanol, you have and you have propanoic acid. Okay, ethanol, it's drawn up for you. It looks like this. Okay. H. Okay, plus the alcohol. What's the alcohol? Sorry, this is the alcohol. What's the acid? Propanoic acid. Propanoic acid, by the way, is what? It's C2H5COOH. Remember, for acids, by the way, propanoic acid. For acids, remember, you start at N equals 0, right? When it's propanoic, when it's 3, you use C2, right? So plus this C2H5COH, and you have the double bond over here. I should have swapped them. Yeah, let me redraw it for you. Okay, I drew for you propanoic acid. I told you it's C2H5COH. Okay, so it should look like this. Okay, you always start with your carbons, C2H5, then draw your functional group COH. Okay, remember COH, C double bond OH, right? Okay, for the alcohol, I drew it with the functional group on the left instead of on the right, so I can add them easily. Okay, CCHHHHHOH, right? The alcohol ethanol is C2H5OH. It's drawn up for you. Okay, anyways, so what do? You take the OH, you take this. What's gonna be left? You're gonna get CC, H. I'm starting from the left, huh? H. Okay, C double bond O. Okay, this is done. Bonded to O, bonded to C, C, H. Okay, what's our ester linkage here? It's this C double bond O. Okay, let's take a look at the answer. Yeah, this is it. That's pretty much it. Okay, so if you forgot how to do it, just do it this way. Okay, if you don't know how to do it, I'm telling you, just do it this way. If you want a shorter way, let's take a look. Ethyl propanoate. That means you can do it. Always start with the acid. Propanoate means how many carbons? 3. So you can just do this. Okay, and you know it's double bond O, right, for an ester, and then just fill out the hydrogens. Okay, bonded to the ethyl. Ethyl is how many carbons? 2. So once here, and just fill out the hydrogens. You can do this as well, huh? Knowing that an ester has this functional group, okay, you can just do it like this. Start with the acid. I'm telling you, anytime ما في شيء, always fill it out. So ethyl propanoate, I told you, if you want to do it quickly for an ester, start with the on the left with your acid, propanoate 3 carbons, so C, 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 and you know that this is, since it's ester, this is the functional group. Okay, the other one's ethyl, so how many carbons? C, C. Okay, then what do you do? We have these C's, they're just unknown. What do you do? Fill them out as hydrogens. And this is the same exact structure I got. 1 2 1 2. طيب show all bonds and atoms. Okay, proteins are formed. هذا السؤال ما بده يخلص. Proteins are formed from the polymerization of amino acids. Draw the linkage that bonds the amino acids in a protein showing all atoms and bonds. يا الله. طيب amino acids. How do they look? This is one amino acid, right? Right. You have NH2 over here, and you have here you have C double bond O OH. Right. Draw the linkage that bonds amino acids. Let's bond it to another one. It looks like this. Just copy this one. C H R prime. You can call it R prime or whatever. C double bond O O H. Okay, when they bond, what happens? This goes out. This goes out. What do you get? NH C H R C double bond O. And then just bond it. N H C H R prime, bond to C double bond O O H. Okay, so it looks like this. Okay, so what's the linkage? Not that, sorry, this, right? This is the linkage. So how do they draw it in there? Let me see. Ah, they just wanted the linkage. Ah, nice. Okay, if they want the linkage only, you guys know that the amide bonds is just this, right? C double bond O bonded to the NH, right? That's it. Okay, showing all atoms. Okay, I think that's just what they wanted. Consider the following organic compounds. Which compounds have the same structural formula? Let's take a look. It should be C and B. They look like they have the same because they both have a carbon double bond, and I think if you count the carbons, you have the same amount. So B and C. Yeah, which structural formulas represent a hydrocarbon? A, B, C, but not D and E. Why? Because they have chlorines, right? So A, B, and C. Which structural formulas represent an alkene? You have to write them down and see their formulas. Okay, so 1, 2, 3, 4, 5, 6. So C6. How many hydrogens? 2, 4, 6. 2, 4, 6. So 12. Okay, is the hydrogen double of carbon? Yes. So this is alkene. Again, this one. Okay, so if you count it, you're gonna get C6H12 as well. If you count this, you're gonna get 2, 4, 6. You're gonna get C6H12 as well. So you're gonna see that for these three, the hydrogen is double of carbon. Obviously, these aren't alkenes because they have chlorines in them. Huh? Type. Someone might ask, why isn't A structural isomer? Isn't it both? Aren't they all C6H12? Yes, but you need to know that the structural. Which ones have same structural formula? They need to look the same. Here you have 2, 2, but here you have 1, 3. Okay, you're tempted. What do you use 3, 1? I know. Okay, but it's the same thing. 3, 1 is the same as 1, 3. Remember in chemistry, you can count from the left, you can count from the right. Okay. Which compounds are isomers? Okay, like we said. What's an isomer? It's same molecular formula, but different structural formula. So you can say A and B or A and C. B and C are not isomers. They're the same structural formula. Although they may look different, they have the same molecular formula and same structural formula. Okay, so it should be A and B or C and we forgot about D and D. Okay, so A and B or A and C as well as D and C, because look, it's the same thing. C2H4 Cl2. This is also C2H4 Cl2. I forgot completely about D and E. And look, here it's ClCl, but here it's ClCl like this. Like one is on the branch outside. Here they're both on the branches inside. But they have different structural formulas. Which compound is 1,1-dichloroethane? Okay, akid it's not going to be A, B, or C because we're talking about chloro. 1,1-dichloroethane. What does that mean? They're both on the same carbon. So is it this one or this one? Are these on the same carbon? No, it's going to be this one because they're both on this Cl. Right? Type. Let's continue. One of the organic compounds represented above is a product of a substitution reaction. Another one is a product of an addition reaction. Which compound is a product of substitution and which one is a product of an addition? Let's see. I look, you don't know, but let's take a look at the solution. The substitution is D and the addition is E. Why? Okay, I just figured out why. When they're both on the same carbon, okay, this is substitution. Okay, when they're both on different carbons, it's addition. Why is it addition? Because it's addition because what's it called? Because when they're on separate carbon, when it's addition. Remember we have C2H4, right? What happens here? C. They break this, right? And one Cl goes here, one Cl goes here. Okay, in other words, they're on different carbons. So when they're on different carbons, it's addition. When they're on the same carbon, it's substitution. Okay. What are the products of the incomplete combustion of compound C? Compound C, it's C6H12, right? Incomplete combustion of it, C6H12 plus O2. Incomplete يعني you have carbon monoxide formed and water. Type, let's balance it. You have 6 carbons here, so you put a 6 here. You have 6 here. You have 12 here, so you have to put a 6 here. So you have 6, 6, 12, يعني you put a 6 here as well. So 6, 6, 6, right? شوف مش ما بدهم equation. What did they say? What are the products? Ah, carbon monoxide and water. Okay, of course. Yeah, that's easier. That's way easier. Okay. Petroleum is separated into man. Aha! خلاص. Discussion doesn't want to finish. Petroleum is separated into fractions as shown below. What's the physical property used to separate petroleum into fractions? Okay, this is boiling point, right? Because what separates between them? Boiling point, right? Boiling point. Which fraction is used as a binder in asphalt for roads? Okay, the one for roads, remember it was the one at the bottom. If you look at the notes, it's all the way at the end. Over here. The one for roads is bitumen. It's the one at the end, okay? You're not expected to memorize the names, but you should know the boiling points, okay? Identify the most volatile. The most volatile is the one all the way at the top, so it's refinery gas, okay? Which has a stronger attraction between its molecules, diesel or gasoline? Let's see, diesel or gasoline. Obviously, the stronger one is the one that has a higher boiling point, right? And we know that the ones at the bottom have the highest boiling point. So as you go up, the boiling point decreases. So which one has a higher boiling point, gasoline or diesel? Diesel. So therefore, it has a stronger attractions. Name X. What is X? Oh shit! So you need to know the names. I have no clue, wallah. Naphtha. Okay. So you need to know the names. Yeah. Good luck, guys. Memorize these. So bitumen, lubricating oil, fuel oil, diesel oil, paraffin, naphtha, petrol, refinery gas. Okay, you have to memorize them شكله. طيب, also the only one missing is naphtha. So yeah. Okay, last question. Oh, perfect. How many different types of monomers the following polymer is composed of? Let's take a look here. What repeating unit do we have? We have CCHF, HF. Okay, so as you can see here, it's just one monomer, right? This being repeated a few times, right? So it should be one type of monomer. A. Wow, we're done. Organic chemistry. Maybe 3 hours. Good luck, and thank you so much for watching.